Yeah.
Just watch the nature. Get an area pitch. What's going on?
I think that professionals. That's you. Professionally keeping things going.
I want to see those things like
Tell
top
me what animal we're looking at other than broad spectrum. That's awesome.
That's a crab.
Probably.
See? Halfway home. Just give it some dramatic, plus story.
It's awesome.
You're going to tell us a story? Let's go. Tell me.
Constantine the crab is having a welcome day today down by the vents. His two closest friends. You gotta get in there for a shrimp.
Same.
It's gotta be an S, right? Staying with shrimp. So, his first day of school yesterday, so he's pretty tired. Gonna be birthday party day.
Birthday party.
Yeah.
Whose birthday?
Let's find someone.
Oh. So we're at Chimney 1 now.
Mm-hmm.
So we do have another place called Mussel Bed.
I think I saw that on his map. There, yeah.
Yeah.
Amy, did you call it Chimney 1 since it's the first chimney of today's dive instead of
This is called Chimney 1.
Birthday.
Chimney 1?
That's the name of its marker.
And, okay,
Yeah.
so that was also the case yesterday.
Yes.
Got it.
What's his name? Or her name? Cecile?
Fantastic. Cecile crab.
Cecile.
Cecile crab, very sad. No one coming to the birthday party.
Did you see those worms?
Does that mean the black stone that we visited yesterday was considered Chimney 2 and not Chimney 3?
I don't know which one we visited yesterday. We have multiple smokers. So they're named
The one
smoker.
that's like 30 meters tall, the huge black smoker from yesterday.
Did Jill
Smoker
sample
four.
it yesterday?
We did the super sampling on it. I don't know if Jill sampled it.
I don't know. Jill did Smoker 3 yesterday. We also saw Smoker 4, which is quite close to Smoker 3 and also big. Smoker 5 is the one with flanges. I don't think anybody sampled there. There's also
I guess
Smoker
in-
1 and 2. I wasn't on for the whole dive yesterday.
Okay.
Back up.
Is it also possible to get a pH measurement on the super sample?
I would think so. We have to turn on the IGT for that.
No, we
No.
have the pH probe that Pete has in the coral liver.
We would have to get rid of the temperature probe.
Yeah, if you want to keep monitoring temperature, we can.
Okay.
If you want to swap it out.
Is this the RNA later sample?
Yeah, it's going out of range.
Right.
We were in here at first, and it was staying mostly between 10 and 20, but it's been.
Do you want us to move just a
dropping.
touch?
Yes, please.
I think you need to go to the. If you look at sit, I think you
We're
need to
gonna
go
have the RNA
down
layer
to
over it
the
yet,
black
so
level.
we're
You
not
got
happy
stone,
with
right?
the fact
You
that
stone,
there's
check it
traps.
out.
We can
Campfire has
probably
moved.
water because I think I like that
Give it a
actually
follow.
with RNA over it.
Get it
Yeah,
that way.
faster.
But in my experience, it's very hard to get the super samplers in any temperature range. Just since we sample so long, it's okay. Looking things when they're pouring.
Are you in it? Are you in the toilet right now?
It's way too hot still. Back there.
Yeah.
talking about?
Yeah, that's fine. Yeah, Pete was saying that at this temperature, the pH probe should equilibrate pretty quickly.
Back
So
there,
you only
as
need
soon
it,
as I throw.
you only need it on it probably for like 5 minutes.
I think we are.
The only thing is, hopefully we
You ready?
have time for that, but we
I'm gonna
started
slide
this,
this in my phone.
I don't know,
Follow
we
me.
started trying to find the right
Let me get
temperature.
your global on that.
Do you have it in your log when we decided? The thing is, the bridge gave us 40 minutes.
That should be it right now.
Okay, so I don't think we'll have like 40 minutes by the time we're done with this, but it is possible we'll be calibrating the pH level before we actually get it.
Okay.
So if you want to pull out the temp probe to do that
I
during
think
the
that'll come
sample,
back up.
we can do that with it.
I think we're in a good spot for the
The shifting.
the shifting of the temperatures.
You guys going for easy?
Yeah. We're close to it.
We're back in the good window now.
Yeah, well,
We were.
it's a plume. It moves. That's what plumes do.
It's coming back. Come back. Earn it. Come on. Come on. That's about to go up. It's not going up. It's all up in there.
Is that we're seeing it from the top to the top?
Coming up a little more. I'm gonna freeze right here so you can get where I'm at. That looks good right there.
Hey.
27, it spiked up to 27, but sitting at, is that fine?
This is 20 meters away from the coordinates that are on the.
So these
How's
coordinates,
that temperature?
and then this is marked
Is that too hot or?
It is probably a little too hot, but I mean, it might rapidly drop any
91,926.
moment.
Yeah.
So that's
I
1,
guess in the
2,
next
3.
10
The fourth
seconds, we
digit is
have
10
to
meters
keep
difference.
dropping.
Keeps dropping,
And
but like if we see
the
30 move.
1, 2,
Yeah.
Got it.
3, 4. I think the fourth digit is 10 meters. Or is the fourth digit 5 meters? Let me check again. Okay. So 1, 2, 3, 10 meters. 1, 2, 3, 4.
10 meters.
1, 2, 3, 4. No, I can't count. 1, 2,
ROV bridge.
4.
Go ahead out.
Hey Joe, it's under, it looks like about 5 minutes past.
I hate
I think we'll have time for the super.
this is where we're going. It's like 100 meters away in multiple directions.
Into our camera.
Yeah.
Or maybe to the right. I'll follow you.
I'll put that in the chat.
Dangerous proposition.
This is from last dive, right? Yeah.
Yeah.
They're saying 5 minutes past UTC time.
Yeah, or
4, 8.
whatever
yeah.
time you really want to look at it.
Yeah.
studies. That would be.
So that's when they're gonna ask us to move. How's your pumping going?
It's coming back at us right
Are we gonna make it?
We'll make it, I think, with the super, but Rachel wants that pH now,
you're right.
and she says it takes 5 minutes to calibrate, so I don't know if we'll have time for that.
I don't think so.
now. Science, it looks like we're
How many
not-
minutes do you have? You don't know how many minutes in
It
the
doesn't
pumping?
tell us how much is left.
So we have 9 minutes left here. So
Well, I guess I told you the time we started the actual sample. Do you have that now?
That's 11.
Wait a minute, this is
Alright,
mass
so you-
sample from last dive.
Okay, it just completed. I'm not done yet though. I have to do the RNA later still, but that will take only 30 seconds.
3953.
Yeah, these are the these are the coordinates, but this is SO. This is 563 masses.
Yeah, so this is what's in here. So that's what
Yeah.
we're avoiding.
Yeah,
But that and this are different.
yeah,
And this is more than 20 meters away from this.
yeah. Oh, okay, this is okay. Yeah, no, I got confused.
That's okay. Ridiculous.
It's just in time for the temp.
Okay.
No, okay.
It's all fine.
Same as with, I think,
See, you can't let go of the other.
I'm doing
the mussels were and clams were collected from the same area.
I guess if we have Rachel is not back, but she says it takes 5 minutes to calibrate. Do you think we have time to do the pH probe?
You guys want to try it?
Yeah?
So we have 8
Okay. Thanks.
minutes to do it.
Yeah.
See
Five minutes
more
long.
clear.
Alright, so stow these or keep the super out?
If you need one of them as a
Keep my
reference
eyes
for
out.
where to put the pH probe, then you can leave one out, I guess.
Are we avoiding 20 meters for the clams too?
Yeah, but I don't think we have sampled from this clam Q3 site. So from either of these, I think.
Let's look at the distance. 21,104. That's like 20 meters this way and 10 meters the other way. So it's quite close. Clams 3. This is also quite close. So
Clams 1 is. This is further away, huh?
yes, that's further. So that's what you want to go for. Clams 1.
Possibly.
Okay. I'll note this.
If we could get some, I think that's. I mean, this is what I got from the log that the clams and mussels were collected from the same spot.
Okay.
Can I borrow your maps that are up there for right now?
Yes.
They're the same, different size. Okay.
Is yours, this camera back?
Yeah, just went to Joe. Good call, right there. Or, it is last thing.
Great. Thank you.
You're welcome.
Let me see if I can come up with folks just a second more.
Yes.
I'm gonna go see if, so I wanted a 5-minute pH if
Yeah.
possible, but if Jill is measuring pH on the IGTs, I won't do it.
Okay.
So I'm gonna run
In
it.
shipboard or in situ?
Yeah, you're on the
I don't think she's doing in situ.
No, I know, shipboard's not perfect, but I'd be satisfied with that.
Okay.
So let me go ask her,
Okay.
and if she hasn't, then I'll run in,
back here.
and if we could do 5 minutes before I move, do we have to?
We're counting down from
Okay.
7, so it's going to be tight. But we're shooting 4.
Pitch out?
Yeah. And I have a shipboard pH meter if that helps.
Good point, thank you, so do I.
Okay.
Pitch up, pitch up. There you go.
So she does measure pH, so that's
Okay.
good news.
Okay.
Jill just wanted me to convey to you that. Guys, no. Sorry, Amy, it's your watch. Do you want to?
What's wrong?
We're coming back to do sulfide, so she
Yes.
suggests if we could do it there.
Okay. It's not going to be the same spot we're already sitting in. But
Is that right?
Well, I
Does
mean,
Rachel want
the
it
plume
specifically
is.
for this super?
We can take a plume pH. It's just
For
the
5
plume
minutes.
moves. So like if you want to hit exactly
point.
where the bond is.
Okay, with your permission, let's do 5 minutes here and move on.
Okay.
Do we have 5 minutes still?
Yeah, you'll be fine. I'll get it for you. If we can get it out of here. Yeah, it should.
Oh, they'll do this, they'll
Yeah.
connect that to zip tie.
Yeah, I'm hoping that zip tie pops and it'll flip over. That's what we'll do. That zip tie break. Out this, shoulder left. Once more.
Yes. We're gonna try
Shoulder left.
the muscles marker and the glues one marker are the farthest away. So this
Yeah, that's why I wanted you to go left.
Yeah, those are different from yesterday. Those are different from yesterday. They're more than 20 meters from yesterday's spot.
Yeah, we're, I don't know. I need you to just break that zip tie, so if you shoulder left, it should pull that rope hard enough to break the zip tie.
Which is right on
The one bottom on the milk crate, holding the lid down.
Okay, I thought it was tied down.
It's tied down there, but zip tied down as well, to keep that in there. Elbow up. I don't know that we're gonna be able to get out of that with this arm. I don't think we're, no, I don't know that we're gonna be able to get it.
Okay.
Yeah, because it's the way it's in a bind.
Okay. So we can't get it out at all.
Well, we can, but we'd have to get rid of that heat probe
Step by step.
Okay.
and use the starboard arm.
Let's move on.
Okay. He's
We'll,
good.
we'll try again when we come back for the chimney set.
Okay. We're okay to.
Yeah, just let it go.
Really large flexible. Where we did some.
Go and press it. No, we'll do it to starboard arm. We're in tight. Just come out of there.
Yesterday,
It was.
because that's what I have in here, but I had called, well, because apparently chimney 1 is chimney 2, so I don't know if there was a chimney 2.
I'm sure. I would not be surprised if there wasn't.
Okay, what would I,
So our
how would
naming
I
scheme.
determine this person?
I think that this is one of those things that would be a good home exercise after the stock. To ask Carl or someone how to use sea log to go through the really pop it up because sea log's still clumsy. Do you agree with that? Does that make sense?
Yeah.
Does it answer your question? Cool.
Michelle, are you still pumping?
No, we're
Okay.
all done. This
Okay.
is-
So we can move when the bridge needs us to move.
And you can shut this off as well.
Super off place.
Super is no longer super. What's the next thing we're gonna do after we vessel moves?
We're gonna come back here
Mhm.
and we're gonna take down the chimney.
Okay, so we're not gonna need the high temp probe?
We're not gonna need the high temp probe unless. Do you want to try and get a pH measurement when we come back, like paired with the temp probe, or do you want to just do pH?
ROV ready? Are we looking?
Oh, we're good to go. Whenever you start
I'm not
measuring
sure
out,
what
I'm
the
writing
motivation
off
is
there and
for
follow
no
you.
temp.
Okay, perfect. I'm gonna move
Which
towards
has its onboard temp probe.
Okay, so you don't.
Sample, so that was
So that means on
Yeah.
Well,
Seems like it would be ideal.
Don't stow
temp-
yet.
temp probe, but it's not
Must be
ideal.
able to see what they're doing.
Okay.
You can go ahead and just stow your
I would
arms.
say minimum we can get in the plume maybe about 10 meters, or sorry, 20 centimeters off the surface, something like that.
So we didn't do
Yeah,
a
just
40
some
C
perfect.
sample. We did a
Yesterday.
10 to 20. Oh, yesterday's. Okay, I'm not sure exactly where that was, but we can always.
Yeah, no, I saw a frame grab. It really wasn't very far off. It was
Okay.
kind of caused me. That's the one where I think Roxy was like, oh, it might get too long.
Okay.
But I think Amy was kind of like 20, 30 centimeters.
Okay. Well, if we have that one out, then we can watch it and make sure we hit that number.
Yeah, that's
But-
yeah.
Okay,
Happy either
so
way.
keep a hold of the temp probe, because we're gonna use it first time?
If you can.
No, I just,
Okay.
I don't wanna stow it and then us come back and that be the first thing we have to take out.
Yeah, we're gonna try and get a pH, and if we can get the pH paired with temperature, that's helpful.
Around
Would it be
40.
good for you to turn the clothes off? Yeah, that's good.
Michelle, did you do both the regular and RNA later super?
No,
Just one.
just RNA later.
Do you still need to do the regular one? Or
Don't believe so.
okay.
Yeah, actually, we were supposed to.
It's in the cruise
It's in
plan.
But yeah, it does look like it's in the cruise plan from our conversations yesterday. I was under the impression we were not. But the cruise plan does have that, so.
Okay.
But we're coming back to this Chimney later for IGT work.
We're coming back
We're
right
asking
now.
about RNA later.
We just did the RNA later.
Correct. So that's that's done
That's
for today.
done. But according to the dive plan, we were also supposed to do a regular at the Chimney.
Do you want me to go double check on
Outside
that?
ourselves, we can set.
Sure. Or I can also text the group. But I don't know if that's.
Yeah, you can bring me in a little
Yeah,
bit.
she's in the computer lab right now. I didn't mean to point at the screen. This is in the computer lab over there.
Yeah, I guess we can confirm. I mean, if it's in the dive plan, it's probably what she ended up deciding. But for some reason, I was under the impression yesterday when we had our conversation that it was just going to be RNA later.
Yeah, I think it'd be good to confirm. So we'll do the next super, the regular super, assuming we do want to do it, and then we'll do pH, and then we'll take down the chimney.
Right. It warms my heart to hear you talk so, I don't know, like cruel. Get down.
Well, it's generally what it amounts to. So.
I have a request in for quotes for a hydraulic chainsaw.
Oh, yeah.
Hydraulic cheese.
Yeah, I think SOI needs one.
I did send them a link to a nice big shipboard rock saw.
Oh, that is cool.
Yeah.
Nice. Okay. I also think the ship needs a massage chair. And then as
No. Soups.
my oh my goodness. All right. Go big or go home.
Yeah, birth of opportunity, that's what they called it.
If we're talking about net amenities, I would take a swimming pool and a rock wall.
Yeah,
I'll
see,
take
there
a
you
rock
go.
wall, definitely. We were talking about that.
Really?
Well, there's enough space in various places. We could actually build one.
Yeah.
So find a spot.
And you've got harnesses and ropes.
I'd help you.
Need a container standing on end.
Yeah,
Right
wow.
there. 4 different rock walls that way.
Yeah. I think we were thinking more of like a bouldering wall, just small. Yeah. Over. Yeah. Walls and
I think you were thinking of something less ridiculous, is what you mean to say.
I mean, rock wall with the crane.
Sure. Yeah.
I mean, if you open up the moon pool and put like a nice little cage in it, that's a swimming pool,
That
right?
is a, yeah,
You
it's a
got a
sort of,
pool, so you do a
right?
dive. What do they call those?
Cage dive?
No, what? Yes. I was thinking that when you jump out of the rocks in the water.
Cliff jumping?
Yeah, well, not quite.
But
Rock jumping.
yeah, but I'm liking the cage idea. You just scoop the scientists up at the end of the
Yeah.
swim club.
Yeah, isn't that the whole reason we don't do swim call? Because people are worried about sharks?
That
Put
is
us in
a
a
very
cage.
good point.
Yeah.
Whatever I can do to help you write the next SOI proposal, you let me know. I just want to be on board.
It's about fostering experiences with the ocean.
It is. It really is.
Lisa says hi. Everybody.
Hi, Lisa.
Hola.
Hello.
Hello. Hello. Hello.
Is there a camera?
Yes, we'll be doing replicates.
Okay.
Okay. Great,
I
confirmed.
replicas you need 1 or 2.
Well, I don't know if Rachel and Maggie and Katie had talked about doing them like back to back to make them as true replicas as possible, so they could compare their results. And we're able to do that with this interlude, but I don't think that's like gonna be
Yeah, the
Their
one's
research,
gonna
so
move
that one gets a
anyway.
big
You
deal.
saw the temperature fluxing.
Yeah.
We're gonna get
I
in that
agree
same
with it.
range. Yeah.
100% agree with you know, replication at a vent is a very loose term.
yeah.
As I'm sure you know.
Right.
That's okay, so 1 more super.
One more super at the
Yeah.
many more supers.
I don't think we've been
Oh,
there before.
surprise. Where are we?
We haven't been there before.
No.
Another vent.
Are those sponges? They
There's a lot of sponges.
Are we smoking or are we not smoking?
We'll
That looks kind of smoky.
Make an observation.
See a little bit there in the background.
Yeah, we're smoking. Okay, so this will be smoker 6. Can we drop a marker, please?
Look at that beehive. It's dramatic.
About how high up on are we? 6 meters?
That is correct, but I'm at the top of it, so.
You don't want to give it a better name, let's book your 6.
Nope.
Yeah,
Smoker 6.
so about 7 meters. Want to see how hot it is real quick?
If we're floating and we have no like.
I have a temperature plug.
Sure, yeah.
It's right there. I can put it inside the top.
Temperature of opportunity.
Freeze it right there.
I'm just thinking, like, we keep seeing all these beehives,
Mm-hmm.
and maybe it's just novice me, but it's like, how come we all have beehives? Doesn't that imply that they have beehives and they topple up and they grow more beehives? Like, constantly?
Mm-hmm. I
So
think they
never
also
like-
recrystallize.
Or they
If
do?
you, I don't know, if you look at some of the structures, that's what they look like to me.
Right. That's
Yeah.
a good point. I see what you're saying. I see what you're saying. So it's kind of like beehive crystallize, next beehive, next beehive. Yeah. Oh, that's so cool.
Whoa, hold on real quick. Give me a second. Bring your arm out.
I'm going to head back to take a sample. I relate what you told me.
Yes.
I should
I'll come back to
be
that.
Whatever it is.
the images for the clam and the mussel markers, and the ones that are furthest away look like it's not a good spot for something.
Not a good spot.
They
Okay.
look really sparse.
Okay.
So I think the best option would be talk to Roxanne to maybe hold off from the animal samples until the very end. So we would do some things with Johan's DTS, and maybe once we're kind of going around the area a little bit more, maybe we find some new spots.
Okay.
If we don't find new spots, it would be great to go back to this area where there's clam bed 3, which is kind of in the broader area of Chimney.
Just move away from where the sample was before.
And just kind of maybe go back to the coordinate and then move out 20 meters or something like this.
Got it. Can do.
Yeah, it's beautiful.
Just so I have like basically some kind of separate patch.
Yeah. Sounds good. Thank you for that.
I just felt your weird. Great. Sounds like a plan.
Woohoo! What's this creature?
Oh, watch this. It's a little defensive posture.
Ooh. Is it gonna bite us?
Cheesed off.
Oh.
Definitely annoyed.
It is scarier when it's like that.
Basically, I'm kind of a little uncomfortable.
Pete, what would you name this?
It's a Dumbo octopus-ish.
Yeah.
Ish.
Yeah.
That's right, they are. That's That's why I was like, ish.
Like a stretched out one.
Yeah, like a stretchy Dumbo octopus. Yeah. They do have the little flappies, but it puts it down when it's mad at J-Rod. That's amazing. So that's so cool. J-Rod, how many of them do you see do this just arms out as opposed to the curl up?
These bigger ones with the spiky suckers always do that.
Oh, they do this?
Yeah, the regular Dumbos do not do this.
Right, right.
I don't know the difference between the two of them, but
Yeah, neither do I.
Yeah, that's true.
Great job.
I'm going to take a picture and send it to my cephalopod buddy.
Woohoo.
we came up just a touch.
Are we sending that to Brett?
Yes, exactly.
I'm gonna come down as we pan up.
Dr. Brad.
Yeah.
That's it.
Got it. And I will send it to Dr. Steve as well. They know.
Oh, it has holes in
Maybe
it.
out someplace.
Here we go. Hi.
Wee.
Are you going to bite me?
It's got a little hole.
Yeah.
It's got a couple holes in it. Yes, one.
Oh,
I didn't do that.
J-Rod, you get some kudos.
What a fancy twirl.
All right, sent it out. We'll see what the professors say. Oh my lord.
Yeah, it covers up its eyes.
Right.
Buddy, I gotta go.
I think let's start with the other.
Don't worry.
I was just learning a bit from Amy about chimneys
The
because
thing that sucks about the hat is when you see something on it, it's definitely significantly prior to you.
Oh, more skeet eggs.
I think we see like a large abundance of them, yes, but like not probably a single one.
Okay.
I mean, I think if you're gonna mark them, if you're gonna log, I think logging them, you should log them, as taking photos quickly. But I don't think we need to have a marker for all of them or something like that.
Cool.
Yeah.
I asked the ship, I said, why does the ship have a list of certain things? He goes, and I was really surprised by that list. He said, we'll do that on purpose. Right on, because they were Russian guys. And I was like, do you know that half the scientists were speculating that maybe I love this idea of let's tilt the ship so it's fuzzy. Let's flood everyone bathroom too.
Wait, what's the answer?
They've ballasted that way so that they were scrubbing the deck to wash it down. Right?
So that's why they weren't,
That's what it
showers
should.
were
Yeah.
draining today?
No, that's well, maybe today, a few days ago, but they were
Today, I've only
doing.
experienced it today where I showered and it just had pulling.
Oh, really? Oh, that's interesting. Yeah. Well, that is strange. That might be a different pump. Yeah, right. Depends on what else it is. Who's standing where? But no, they said they have giant ballast tanks because they have such big frames. We can trim the ship, a few degrees.
Do we completely balance that with ballast or is there other, I'm just wondering.
Talk to Captain Phil, he will be your ally. I think he would like that to happen.
I'm gonna go back to that. I just been back to the turn. I just spin around in circles too, I'm not. I don't think that that's for sure.
Well, it's just a box in the ground, right? That's fair.
I have that in there.
But yeah, there it is.
Did they sample that water?
Ew.
ROV bridge.
going back to the Chimney.
Yeah. Yeah, once, I don't want to drop down this thing right away.
Yep.
I want to wait for him to
No problem.
come. I'll just probably follow this for a little bit more.
Yep, sounds
Once I
good.
think he's over, I'll hit stop.
Great.
Just keeps going.
Good afternoon, folks. Pardon for the little sound interruption there. We're headed back to explore some chimneys. You can see that on our little pilot map there.
I don't know why.
And meanwhile, we're pretty much beelining straight to there and enjoying some views of pillow lava.
See the sea star?
That's a nice sea star.
It's cute.
About 20 meters right
You guys saw a dumbbell?
We did, yeah.
there.
I'm totally not jealous.
It was one of those ones with like the really furry, when it opens up, it kind of looks spiky.
That's really cool.
Hey, Cusco.
Cuskeel, hello.
I'm pretty sure it's a Cusco, but if I get closer, it might be the bony ear one.
Wow.
It's bony ear. Pretty sure that's a bony ear. I can't say the rest of the name, you're gonna have to.
Oh, look. You're looking at
Peekaboo.
Oh, no, that's not the bony ear, that's just a Cusco.
Look at its cranium. Its noggin. It's a big noggin.
It's like bald head. It's all brains.
Alright, but then I gotta go the rest of them together. Alright, time to jump off the hill. Y'all ready?
Here we go.
Good job, everyone.
Is it becoming loopy hour at like 5 p.m.?
2 mini crews for this to start happening.
Yeah, oh no.
Who's your daddy?
Oh, hey.
Is that an orange?
Who are you?
Hello something. Kind of sounds like a dinosaur.
Oh, Halosaur.
Dinosaur? Dinosaur?
Halosaur, maybe.
Oh, that's a
Oh, that's a nice one.
Oh.
Bass boy.
Bass boy. I love that.
There's some good sediment.
Would you like to note it?
Sure. I mean, I can't tell super.
It looks pretty much the same. I'll try to get down for you real quick. I need the vessel to get over that cliff.
Maybe it just looks decent from above.
Yeah, it doesn't look that different.
Maybe not.
Yeah. Never mind.
How you doing? Good.
So, I'm not pulling out having those pilot wheels.
Did you?
Off the port side.
Just now?
No, it's like half an hour ago or something. There was literally a couple of
I was
crests.
outside half an hour ago on the starboard.
Really? Maybe it was a bit longer than that. I was standing just before I went up for there.
Yeah.
Standing at the same time. I was seeing them.
That's amazing.
In the back of the vessel, and I went to sit on the side.
Yeah. That's amazing.
Slow down.
Oh, I'm so happy for you. That's amazing.
0.5 now.
Hi, baby. Checking in on our progress there with the pilot map. Making our way on over.
All that area right up there. I'm just going, I was trying to go downhill. I'm trying to rotate to the west.
Thanks, Roxy.
Of course.
This looks like it should be a flat area according to that.
Not flat.
Oh, I think we decided this morning that we're 20 meters offset.
Yeah, but even that, I mean, I guess, yeah, that would be that wall right there. Okay. No, I'm gonna fix that up.
When y'all place like a marker on the map, how, I guess, is there a, how accurate is it, quote unquote? Like, it's easy to find stuff?
Very easy.
Yeah? Has it ever been like super off or anything like that?
If we put them on, no. But if we get them from the scientists and they were on a different vessel, sometimes they're 10 to 20 meters off.
Oh, interesting. What does that really depend on?
Calibration of the map of the vessel that they were on.
Okay.
ROV, like, who's calibrated correctly.
Interesting.
Trying to come back down now.
I'm sorry, where are we heading to right now?
We're going back to Chimney 1. Chimney 1. Favorite place.
Spent a lot of time.
Seems like the only place we go.
You want to get here, Mike?
Yeah, sure.
And have a handover with Dougie. So you know where we're going, right?
Yeah.
Alright.
We're heading for.
Yeah. All that jazz.
Yeah, she doesn't want to move a lot right now because umbilical trying to drag it through the water. Both for the vessel driving it. So, yeah. As soon as I was going, I'm going to walk it back. But all yours, sir.
Yeah. Thank you.
Y'all have a good one. I'll see y'all tomorrow.
Yeah, man.
Tomorrow, man.
Good.
Come out.
Hello.
Mike is in the hoose. Get in there. Good.
Just having a bit of a switch over here. We've got Mike as our pilot. Woo! He's giving a wave. We've got Tyler, his co-pilot.
Also waving the TV screens.
Hi out there.
Hi, Chad.
And we've got Chris with a K.
I think the 7 minutes of watching Mike fly.
Welcome back.
How are you?
Good.
I'm not close to that 93 delta.
Yeah, I don't know. J-Dog was leaving it out big. I don't know. Yeah, a white book kind of thing. I don't know. Feels like I'm getting pulled already, to be honest.
Where you going?
Heading, see right in the edge of the map there, lander, marker, climb to area. Yeah, out there, that little cluster, Chimney 1. But then moving nowhere. Moving nowhere fast.
What are we gonna sample at Chimney 1?
First, we're going to do another super.
Nice.
Then, we're going to take a pH measurement.
Mm-hmm.
And finally, we're going to take some chimney.
That's exciting.
I don't know if it's just rope current or what. Maybe I need more delta. I don't know.
84. But I think it's making a big sail behind you.
Moving forward much of the remote head and stuff off just to try and get them more. There's good gain. It's good to gain up a little bit more, what do you think?
What's that?
Gain in the thrusters.
Yeah, go for it. You're in that chair, you can do whatever you want.
Thanks.
Hello to some of the new folks joining us. super happy to have you. If you want to see something really cool, apparently, when I was not sitting here, totally not jealous, I saw a Dumbo octopus. The timestamp. It was nice.
It was really nice.
Go back to timestamp 23/16/08. Thanks to the folks in the chat for putting that timestamp there while we're transiting. If you want to take a look at that again. Pretty rad. We love a good cephalopod. It's like a treat.
Oh, what?
It's like a treat.
What is?
A cephalopod.
Oh, yes. There's something right there.
Okay.
It's going.
It's gone.
Yeah. So I try and do some birds.
It's back.
Ooh, what's that?
That's it.
Got any tips? So I'm giving it full ahead here and I'm looking at where the vessel's catches. And I'm like 50 meters up in the stall. You know better.
Yeah. You only got one thruster.
So that was,
So you're auto thing now?
yeah, all heading back on now. Should be anyway.
Yeah, so your starboard side is not going. Try to lateral to your starboard.
We have a little question asking us about where we're transiting to. There's a little cluster of green points on the map there, right by waypoint 3.
And you turn my head a little bit so facing the
There's also a place
Just
call
go ahead. And also
Chimlet 1, a little baby chimney.
Why is only going 71, 69?
Our watch lead
I need food or anything related to that.
mentioned
moving a bit now.
we're going to take a super sample.
Yeah, I'm just gonna keep.
So that has to do with fluid chemistry. We're also going to take a pH measurement, and then we're also going to collect the chimney.
Just because you push it harder with those things. You want it
Yes, please.
better now?
Yeah, just tilted it with a stick actually. Yeah, why is the thruster so balanced?
I don't know. It might be the connection underneath there.
Seem to be making good headway now, but I've came up to 60 meters to do it.
Yeah, it's still weird that you're getting different. Are we going back to smoke for 6?
No, we're heading over to Chimney 1,
2, 1.
next to Waypoint 3.
Yeah, it's weird. Quiet. Very quiet.
It's the contemplated group.
Like progress has been halted. Now not moving again.
Moving.
I don't know, I must have just hit a bump in the road there.
Yeah. Got like a whole 4 meters since I've been here. Look at that beautiful diffuse light on the back.
Oh yeah, I know. Better than the homemade diffuser.
It gave me a seizure yesterday.
Yeah, it's annoying. Yeah, now when I start coming down, it's not good one of the rest.
When I first saw our little miniature liner, I thought it was a school bus.
Really got to try and turn down, but as soon as I try and come down, I don't get anywhere.
Yeah, you're only got 45 on your starboard, so you're having to rob a lot to stay straight
Yeah.
and not push very hard on one side. So I have a theory. I don't really want to mess with it until you move to a more stable position.
Yeah, and I seem to be moving okay if I lay off the forward command a little bit, but then as soon as you introduce another command, it doesn't want to play ball. I'll get up here and that should be far enough that I can come down a little bit.
Mystery markers.
Going the wrong way.
Some reverts now as well to try and come back down.
I don't think it's the current. Well, I mean, there's got to be some current, but
You have to go off all ahead and stuff as well, just trying to get the most.
yeah, you're stripped to south.
Yeah. Yeah.
What's your gains looking like?
I've put up the verts and 2 packs down the starboard. The axial ones. The axial, the forward and back.
Video out, but
Yeah.
So 3 meters from the launch point.
Give it a try and see if it works. You know, managing to get down but losing elsewhere.
You can come down, you're not going to get overtaken by the vessels and then another 10 years to go.
Okay. Cheers.
Is it the winch? No, it's the pilot. He's having something going on with the axial thrusters. See if he can be able to deal with it once we settle out.
I'm in the right way. I'll get it
You're making
eventually.
progress.
Slow progress.
Delta drop into UV closer to sea. Yeah, still going. Now you go back to camp.
We're getting no feedback from the axle there.
I have an idea what it looks like. Give us down.
It is down at 3, but
Pop it up. Go to like 8. Take the.
it's getting got a lot of command there, but
That should be up close to 100.
yeah. Dropping in out a little bit. Don't let it drop it back a little. Don't really need that one as much.
Right, seabed side.
Wanky. Okay, cheers. Okay, so visual. What do you usually leave the verts at? 4, 3?
3. I usually do them 1 click from 4. So go to
Yeah,
4 and then click it to the 3 one.
Yeah, okay. Like that. What about your thruster gains usually?
Against?
Your
I do them all but the same.
how do you do?
Is your
Tail this back a little bit then.
which one?
Forward and back.
And if you're struggling, push it up. But I don't know. If
Now I've got a visual reference, it might be something like that. Seems to be.
There you go. Look at that.
Alright.
Let's see something actually.
Yeah. Cheers.
Pretty accurate. This is nose. Pretty close to it. Should direct me in front of you. Maybe a little up to your left.
Roger.
Are we getting close to the chiplet?
Pretty close, yeah.
Wait.
Can you power the secret?
Sure can. On.
Should be pretty close to it here.
Yeah. Like, past it.
Past it.
Well, according to the map.
I didn't see no chimneys. Turn around a little bit. over there. This was the one I saw. I think I saw. Like smoke in the water there, isn't it? Must be around here.
Or in the map, it should be to your left, but
Do we know what it looks like? Could this be it?
I don't think this is it.
is it where we were earlier?
It is exactly where we were earlier.
Yeah,
Yes.
so we'll recognize it. It's where we were doing our
Okay.
It's got smoke coming out of it. If the map's right, we're still a little bit northeast of it. In the
Yeah, about
marker.
2 or 3 meters.
Something hot over here. Here he is. That guy? No? Where the J-rod broke a piece off of.
That's
Is that the one?
might be below you.
Might be the one we're
below you.
right on top of.
Yeah,
Yeah.
it might be right below us. So don't come down.
Yeah.
Doesn't look good either. Is it a rubber band? That's more. This is it.
Yeah, looks right.
Yeah.
This guy?
Last year when we were trying to find the 10 to 20.
I was at 315 was my heading, so if you can come up at 315 and see if it looks like what we were testing.
You go all the way to 315 and full turn.
We'll come back around and see.
Yeah, check him around the other way then. So we're gonna work our back here, but do a offset head and spin. Or what? What do you think?
What's that?
Do we need to be on 315 headed?
I don't know, that's just what he was talking about. I don't know what
It'd be
that's
nice to
exactly for.
be in the same orientation we were in before, because we're going to take a sample from the same plume.
I'll come up and
Go around the other way.
yeah, I'll spin the opposite way.
We were taking the temperature. And then that we can see it was
It's much better.
for the position.
You,
Yeah.
you? Just waking up.
166.
When did you get up?
Hmm.
Yeah, trying to get up around 4. So then I'm like cranky. So, sometimes it works, sometimes it doesn't. Video on that.
Oh wait, that's higher on top of it.
We were like buying these like these one. So we had to take the temperature on it.
Which one are we thinking? This one here? Center? Or
It's Paul,
This is
can we come down a little bit? It's
Yeah.
kind of hard to see from this angle.
this is a similar head as what we were on anyway.
Okay.
I think that looks like an ROV inside.
Now it's 8 fish.
Yeah, maybe this low one is where Jill was sampling from. What do you guys think? Is this the one we were grabbing from before?
I don't think it is. If it's the one we were just doing earlier. It's hard to. It is. Well, there's as many big bits where we were sampling before. We'll have a little scoot around.
You could also look back at the IGT photos. See, they're trying to replicate.
Yeah, Andrea had a heading of 168 for when we did the.
A 168 head.
Yeah, which is quite a different heading.
Okay, so I'll come back round to one. Would you say 168
Maybe that loner.
from the other side?
Yeah.
Yeah.
Let's take a look at what it is right now.
Yeah.
That's right. So such a same as it. Yeah, 'cause is this the one that we
We're
knocked
thinking
the
it's the loner.
beehive off of?
Yeah.
Does
Oh,
it
it
look like
is.
this? Yeah, I think so. Anyway, 'cause there was a beehive on the right hand side of it that we pushed over,
Swapped it over.
and
Okay.
then that left this bit.
Perfect.
That rings a bell to me anyway.
Great.
So you said 160 head and wanted.
Yeah. That's what we have on the data logger. Yeah, this looks good. And then, yeah, we can sit down and reach somewhere in there.
Back a little bit. Yeah.
Just start shoveling it.
Tomorrow's dive is at Iguanas.
I'm sorry?
Tomorrow's dive is at Iguanas.
Yes. Yeah. I'm so excited to see someone
sense. It's the same one we're at.
I'm feeling pretty confident.
Yeah.
Yeah. We would love that. Michelle, what do you think?
In terms of whether it's the same gimlet?
Yeah.
I mean, it looks similar.
This looks like smashed beehive down here.
Yeah.
Do you have IGT photos from yesterday? That might be a little less destructive by the yeah. I mean, it's probably right. It looks. I think it looks like what you showed me. But some of these structures
I remember this crab.
Oh yeah?
He was coming to fight earlier on.
We should have put like some nail polish on him to label him.
Yeah, with a T4.
Yeah.
Okay. You found it. Good job.
Flag it.
Wow.
So if you lift that up.
Ooh, secrets.
So they sampled towards the right then? We want to try and sample
Some
the
issues
same,
with the.
it's on the same orifice that they did. But I also want to hear about like the last one.
I'm pretty confident this is what we did the last one.
So this is like, this is from, do the coordinates match? How sensitive is the GPS?
What are we doing?
Let's check.
Oh, yeah.
Let's see,
Did you just bring a camera in? Did you just bring a camera in?
Yeah.
Okay. I didn't see it there. It's all there. It's really tricky.
That's what I say. Lost all the valves on my back.
Yeah, just hit it.
Yeah.
Is there only one like main
Test
orifice
your memory.
on this?
Yeah, the lower one,
This one.
which is what we were. Yeah.
Okay.
Yeah.
Okay.
Could we take the temperature probe out?
Yep. Do you need a little bit more porch out there, Doug, or are you
we doing?
happy? Temperature probe.
I think we're already open.
So we're gonna
Oh,
do
you are.
Dude, talk about being prepared and voice.
already. We'll do a temperature probe and a super holding hands like we did before, and then we'll swap out the super for a pH probe and do the same thing.
Do you want to get here to use the starboard arm thing to get the page probe out, right? Was there a problem earlier? Getting out of there?
No, I think you can just grab the rope.
Yeah, I thought they had trouble with it
Oh, did they?
earlier.
They had trouble,
don't know.
but I don't know what the trouble was.
Yeah, I thought Jared said something about you could get it out the starboard arm, but they would have to let go of
Get what out?
the pH probe. We can deal with that later.
I think before he was trying to swap the T probe for the pH probe.
Or am I trying to take this now?
So keep the super up and then swap the T probe for the pH probe.
Right?
Where are you wanting this temperature probe exactly?
We're gonna aim for a temperature between 10 and 20 C. So in the plume.
In the plume, but a little bit higher up, maybe. That's like 13, 14.
Yeah,
That's a good position.
I think so. If it stays. Yeah.
Move that out.
anybody know what the salinity is of any of the samples that have been collected? Or
I don't think they've been measured yet.
okay.
Yeah. What do you think? You ready to pair? Or you want? Not yet. Yeah, still too cold. Like the Goldilocks sampling. Oh, I think we might be so hot because that might be another orifice.
Probably fast enough.
Oh, it's C. Hi, C.
What temperature are you looking for?
10 to 20 C.
When the first one we took the sample of, it got broken open, so it wasn't as hot anymore. So it might be too open.
What got broken open?
The first one we took the sample of, it got opened up, and then the temperature dropped, so we had to go somewhere else for the second sample. So that one might be,
For the IGTs,
yeah,
they're from different orifices.
yeah.
Oh.
Yeah, the first one was like right here in the front, and then the second one we had to swing around to the other side because it got opened up too much trying to sample it, and the temperature dropped. It wasn't focused enough.
We'll need to look at that too because for the sulfide sample, Jill wants pairing before they take the IGT.
Stop climbing.
If it's sort of from two places. Gotta figure out where those are. Do you recall?
Has it been stable in this region for a little bit?
So the first one was here at the front. Oh, you know, like we're at a different angle. We'll reconsider something here.
Oh, so
Yeah, so we were up here at the front, and then we went around because we knocked the where it's black on the right side. We knocked that off. Yeah, that was the second one. Was on the back side of that. And then the first one was up
This?
here, where it's white kind of cap on there.
Here.
Yeah, yeah.
Okay. It's gonna be hard to get a piece of.
10 seconds.
10 seconds. 10, 9, 8, 7, 6.
Don't do it yet. Don't do it yet.
Yeah, but that's probably it's not very good.
How's your dinner?
There's mac and cheese.
There's cauliflower and cheese.
Thank you. Shell sample from both sides yesterday. That's what you're talking about? There were no IGT samples today, right?
There were 2 done today from here.
And so that's today's one thing got broken? And yesterday did we sample from those same 2 spots?
Yesterday we sampled from the first one that we did.
And is that the side that we're on right now?
Relatively.
Okay. That's where we want to be. Okay. Just confirming. Okay. I'm just going to start flushing, and I guess we'll just probably throughout the sample kind of keep on chasing it.
Okay, we'll keep an eye.
I mean, you're going deeper with the super wand, or are you happy with it?
I think. Oh, with the super one, sorry.
The best use would be.
Oh, yeah, can we poke them together?
Yep.
Yeah, we can get the closer to
Some geology.
So I'm gonna start now. This is gonna be sample. Sorry. Yes.
Okay.
Regular.
I don't know how possible it is, but this is where all the worms are hanging out and a little bit of.
All these red things are worms.
And anything red is a worm.
Okay.
So if anybody hanging out usually in the flow, I don't know how difficult it's going to be to collect these sulfides at the bottom. I
It's
mean,
gonna
that
be
is-
a pain, but we're gonna try it.
Yeah. Yeah, I don't really know if there's time for a slurp. So we've been here a while. But we have a lot of objectives here.
Yeah, we're gonna be here a while more.
Yeah.
No worries, it's in the same area.
Yeah, so you would, now you would prefer we slurp first, do you think?
I think
not worried
so.
about that.
Okay.
Like maybe just a good slurp, we start up here and
Just enough to change the
Yeah.
temperature out of the
Then
range.
start here.
Now I'm up to 25 C.
Sarah, number we're shooting for?
Oh. Well, I'm more interested
Not
in what
really.
we take
Just
in.
I'm more about diversity.
Okay.
It's like these guys are more something I already have. It's just like a parallel vanilla. But I'm looking for this guy who's like half pink, half orange, more leggy. And then scale ones, which are like little pill ones.
Okay.
So it's a little warm.
Fluctuate, whatever.
If it starts really staying out of range, then we can try and move. But it seems like it's close to fall back down.
Yeah.
So I think it's fine.
Okay.
Because I would rather do the slurp instead
Really
of.
touch it because that much gets
There's
right
another
out of the
oh, this
temperature.
one.
Yeah.
I don't want that.
Don't really want it.
Whatever the current
No thanks.
And if we can't have it, no hard feelings.
Okay.
Very, very
But I hope you guys get a good sulfide piece because
specific.
Thank
it's
you.
going to be super interesting.
Okay. Good night.
Good night.
Sleep well.
Thank you.
Night.
Good night. Have a wonderful
Good night.
night, everybody.
Good night. Thank you.
That was flushed with 16 to 22 meters. Oh, and I forgot to mention this earlier, but as a reminder to try and make the word super in the additional text.
And this is super 3? Yes.
Oh, sorry. It was flushed with 16 to 22 meters.
Oh shit.
What was that? We'll recut that a little bit on the cable. In addition, they're superfluous.
Yeah, I mean, I don't know. They went alright, I suppose. They went much of a hassle.
Yeah, it's a little bit more, so still stayed was not for a little while to be like perfect green. If they were really necessary. They would know because we had moved the other 2, 3 and 4 without them, I never had an issue with them.
No.
So I don't really see the value of having them.
What was on those ones? Just
Base right here, it's, in terms of chemosynthetic animals, it's mostly just the mussels,
Coil
but
from underneath
in the general
unit.
vicinity, you
Underneath,
know,
yeah,
for
yeah,
other
yeah. Not gonna go anywhere.
chemosynthetic animals
Yeah.
present.
I think they got some clams here, but I think we're not gonna do another animal sampling here except for Nicole's worms. Corey wants animals from elsewhere.
Yeah, I'm just curious for free living symbionts and what animals are present, what free living symbionts to look for.
From my geochemist dad.
Maybe some plants too. Okay.
Maybe I can look about print. That won't
okay.
mess us up.
A little scan.
Yeah.
Scan in nice.
Yeah.
Whee!
Joysticks and blocks.
Nope.
What's up?
That joysticks like inverted.
Yeah, okay. So when it goes right, it goes left.
Yeah.
Spin it around. Up that.
Yeah. Turn around.
Flip it 180.
Put down. It's a do like that just to trip up the sign.
Yeah. I know that on right, we have us change it, so it might still be what we did for her.
Just left and right though, to go up and down and
Up and down, that one's fine. Our one.
Yeah, so what they would do is they would change the left and right, and then she would flip it upside down.
Oh my
So
god.
that down was towards her, up was away, and then left and right was. So yeah, it's probably switched from her. That's what it is. I never did it. They just said. I think Johnny did it for him. I don't know what the procedure is. John, lead technician, marine technician. I can check and see if anyone knows how to do it. I can give you a text message. Sure, that was. It's like ground right down there. It's okay. See now?
He's cut something short. He's good with Mike, is he? A little bit off, so he's trying.
Wants a fight.
It'd be cool if he just appeared out of fans. Show yourself.
Show.
Shadow puppets.
History of Moscow Blend.
you already text me?
I don't text them. Or more stuff.
Dude, he's texting me all the
Tom
time.
wants to whole asking where stuff was and how much was done, so he deserves it. Okay, that's fair.
So, if you don't know how to turn it, but just text it, just hover.
Hovering?
Get it. So,
No worries.
Nicole's a little sick, because not just getting used to left, right.
Yeah.
That's silly.
Like we're all gonna be acclimated and then we're gonna be upside down again.
Wait till you done guessing.
Camera front.
Yeah, unfortunately, I was here last time, but I wasn't really paying attention. I was just like, okay. That's the thing? Gotcha.
Next is Gage. I don't know. I thought it just acclimated for 5 minutes.
Yeah,
You know?
turn the whole thing
Yeah.
around to see if that makes it
Go here, up and down will be
5 minutes.
full cut off.
I thought they had a more flat, I'm not sure.
If you spin it, then that's down, that's up, and that's down, as opposed to with ours.
Down.
This is down, this is up.
It actually says on the back.
Ours is forward. Yeah.
Yeah, it's
Yeah.
backwards.
Yeah.
Yeah, is there a way?
We could stow the wand.
Okay.
We could stow the super, but leave it on for now, please.
Okay. So we're not gonna tell anybody that we did that, just to see what kind of reaction they get.
Yeah. Yeah, fine. Going into the night shift is perfect timing too.
I don't see that though. From the map.
Yeah.
You sure that way?
Yeah.
Tip goes over. You guys didn't know what you turned it and watered out. You want the lowers on, you're good. That should be alright.
I think you can do the up and down in your camera settings or something.
That's the normal way.
Is it?
Yeah, like your final plane.
But you're not.
In my head,
Sure.
We don't get a live rate of the gauge, right? It just logs.
What?
The gauge. We don't get a live reading, it just logs, right?
Yeah.
Nice.
Do we know what the things on the mussels are? Are those limpets or barnacles? Limpets?
Yeah.
Cool. Crab close up.
We can check the super out.
He's eating something.
Yeah, that's the super
I
off.
think it's like
Ooh.
Fu Manchu.
Oh, what?
Okay. So now, once the super is stowed, we'll pick up the pH probe and put that and the high T probe together like we did when we just put the super and the T probe. And then we're going to leave them out for a little over 5 minutes. And we're shooting for 40 C with those. But we'll
Shooting
be
for 40?
Yeah, we'll be at beta the whole time we're there.
Oh, so we're not trying to get pH that matches with the super
Do you want me
sample?
to,
Pete wanted 40 C to go with
so I'm waiting
yesterday.
porch out, so I don't know if you want to keep your temp probe there or.
Just frequency, then he's collecting data out.
Okay,
So I
I'll
feel
porch
like
out.
once we calibrate, since it's just a flux anyway, and he's gonna end up with temperatures from 10 to 60. Yeah, it's true.
Yeah.
Yeah, because I thought they also wanted it for Rachel. Yeah.
I'm gonna touch it.
We'll wave it around. We'll get all the
It's
numbers.
compliant. It's T4 compliant. Good. More compliant than the
Down with
boxers.
the, his boxers are compliant, they just, you know,
They are.
it's our own decision.
Of course, that cover's gonna be right over the,
I grabbed it.
right over.
I'm mad about that, but I'm the one who put it there, so I'm really too upset. How close do you want this one?
I have to get close to 40 C?
Yeah, 40
I'll have to
C.
get
Right next to it, right above it.
Do you want that porch in a little bit?
Yeah.
Yeah, a bit closer.
That'll work.
Just watch this as we come past.
Should we ask him if he's on? What utilization is like 140 C? So 10 C.
6.5, 10, 14, 15.
You can put the two together and
Eight.
it's It's okay if the pH is recording at the lower T2. It's going to be useful.
It's not fully in, but if you need a little bit more.
Yeah. We're just trying to get a nice data stream of pH.
How's that?
Good, I think. Yeah. They look pretty close. Okay. So yeah, so that's in the great, we're going up.
40.
How warm is it?
45.
40.
Let's keep it. Let's cool it down.
Cool it
Back off
down.
a bit. That's a little too warm.
You wanted 40, right?
Yeah.
Do we also want it to 20 for Rachel?
How's that?
Well, they're not together anymore.
Right, I just
so we don't
in
know.
a cooler spot.
This
Yeah.
is definitely cooler, but
So if you want to get that to where you're consistently 40 degrees, keep trying. And then I'll move you in. Alright, how's that?
That's pretty dang close.
Could you come up a bit, please? That's
So he's
that's
at
pretty good, but it's.
So,
Let's come up a bit more, guys. If you please.
Alright, here we go.
you know, I'll just ask Rachel if she happens to have time.
Okay, let's hold it there. See, that's the thing. I mean, when you're this close to it, it could be hitting a really hot temperature.
Yeah.
Can we come up a little bit? Yeah, somewhere around there.
okay.
Okay, so I'll go above.
Amy, can you see all the white precipitate or microbial mat in the background?
Yeah.
If maybe we can get the black guard on the pH probe not to be below that white line. If that
Okay.
makes any sense. Yeah, exactly.
Okay.
So let's keep it somewhere above that.
But in the stream?
Yes, please. But that should be quite well. I can't tell. Are those smokers back there too? Yeah,
Yeah, they're far bit.
Are they far?
Yeah.
Yeah, I mean, what you're using as the reference point is the next set of smokers, so above that is where it's coming out.
I see. Okay. Oh yeah, I see
so,
it. I see it.
Yeah, back there.
Yeah. Okay, that's fine. Why don't we hold it here? My big worry is that this has a little quartz optical window, and if we heat it and cool it too fast, it'll be a bad day. So.
Yeah. So we started in the smoke around the 55. I don't know if you want to be stable for 5 minutes or just.
Let's see. So what time do we have? Are you all cool going to? Let's see. 5 minutes would be 7:03 local time. How about 7 minutes?
Just for my notes, since the phone is temp focus, if it's much lower.
I'm going to ask him to bring it up. Yeah. Good call. Amy, could you please ask the pilots to bring the temperature probe?
Closer to the pH.
Yes. You are welcome to ask them while you are here. This is your instrument.
All right.
Yeah.
I don't want to.
I don't need to
I don't want to
do
get in
that.
trouble with you, so
How's that?
that's
Better.
fine. Thank you. A little bit. Can maybe even touch the base of the plastic.
Yeah.
I've seen what you do to smokers, so.
I haven't done anything to these smokers yet.
Yeah, well, I know it's good. I know it's coming. Thank you. That's perfect. Thank you. Thank you, Michelle. At the end of the 7 minutes, if you all don't mind, I would love to look at the tip and just see if, I don't know, it would be a little emotionally reassuring if we didn't see anything weird.
was gonna say I can look at it now, but it's blurry. So, yeah. Can do. How frequently are you recording?
5 seconds.
Okay. So once you hit your 5 minutes, you should have a nice stream of values.
It
Or
has.
every time it changes temperature, it needs to recalibrate.
Well, it's a little bit of both. So I'm taking this with a grain of salt, and under these conditions, it's got about 0.1, maybe 0.2 at worst resolution. But like the diffuse flows, where we tip it from bottom water into above the mussels, which were literally 2 degrees warmer, there was a 0.4 pH offset, but like difference. So, you know, it gets a really nice response after 15 minutes. That's when it asymptotes. But this company's wonderful, Amy. If you're looking for any optical oxygen or pH probes, they're really good.
I love
Are you trying to chase a certain temperature range, or do you not care that it's not good?
So if I care that I have some reasonable consistency and it becomes a little dampened here, then closer to the bottom. I also care about the instrument, so if it gets too warm, I'm a little leery of the window. But the thing too, Michelle, is that there's, like, I can calculate the predicted pH based on the temperature, and if I assume that it's hot water mixed with cold water, then I can, and I know the constituents, then I can calculate the predicted pH. And what's interesting is that it's usually pretty close, unless there's a lot of animals. Not even microbes, but animals. Because they will often, their metabolic rates here are so high that a field of mussels like that can really change the environmental pH because they pump protons, especially if they have sulfur oxidizing environments.
That's interesting.
Right?
Yeah.
So I have a feeling that mussel bed, the reduction in pH had more to do with mussels than it did with chemistry.
When's the last time you did a nuclear titration?
Last year.
Really?
Year and a half.
Awesome.
Yeah.
I haven't done one in ages.
Yeah, I was on Iguanas 2021. Old school, buddy.
Yeah.
Gotta, keep the faith.
Gotta keep that oxygen
Go out with my burettes. One of these days, in the post-apocalyptic world, there's only a handful of us who can still do chemistry with our glassware. Right? You need to know how much oxygen? I've got my permanganate here.
Yeah.
No, I teach infrequently, but I do teach a physiology class on campus, and it's my favorite part of that class is students are so skilled in genomics and understanding, how genomes work and molecular biology and kind of the things that I'm really, far less experienced in. But physiology and biochemistry are like a black box, and it's a cool chance to be like, cells this really well coordinated chemical machine, right?
Yeah.
And, so we do weakler titrations, we do chlorinity with a chlorinometer.
Yeah.
We've done elemental analysis with an ICP-MS on cell cultures.
Alkalinity titration?
Alkalinity titration, absolutely.
Nice.
Absolutely.
Love a good titration.
By the way, folks, Amy is like totally awesome at making these electrodes that are a mix or an amalgam of gold and mercury. You should ask her all about it. Like,
How do you do that?
Explain it to us.
yeah, we've got time.
Oh man. So these are really handy because they let you measure a bunch of dissolved constituents in seawater simultaneously. So you can measure oxygen, you can measure peroxide, you can measure iron 2 and iron 3, manganese, and dissolved hydrogen sulfide. And so you're essentially plating the mercury onto a gold electrode that you have to polish. They're not that much fun, as Pete knows very well, because they're homemade. So each time you make one, the surface is unique, and you have to calibrate that unique surface. And it doesn't last forever, especially if you're working in sulfidic water like we have here. So then at a pretty regular frequency, you need to repolish, and replate it, and recalibrate it all over again. So they're handy, but they're not super robust.
They're amazing. It's like witchcraft to them. That is so cool because they work so well. And there's only certain people in this world who can do it, as far as I'm concerned.
We used to have a sticker on a potentiostat that was probably made in the 1980s from Princeton Applied Research, and the sticker said, electrochemistry, it's not magic anymore, and it definitely was wrong.
Yeah, the sticker is a lie.
It's definitely still magic.
No, I mean, I think, and I could be wrong here, but isn't that kind of similar to fire gilding?
No, you know fire gilding is.
So clockmakers used to dip metal in mercury in order to put a gold film on. And I think it's called fire gilding. It's like this thing where you take metal and you put it in hot mercury, and then you do something so that the gold adheres to it.
Well, gold is really soluble in mercury, which is one of the reasons that old gold mines are often contaminated with mercury, because it's a way to collect it from the crushed ore.
Wait, really? So they would crush ore and put it in liquid mercury?
Yeah, sheet it with mercury, and then you have mercury with gold dissolved in it.
1 minute left, by the way.
But that kind of sounds like what you mean with fire gilding.
I think that's it. Maybe they dissolved it.
And then you burn off
and then
the
you burn the mercury off.
which is very healthy for you.
That's exactly what it is.
Yeah.
So that's how antique watchmakers and clockmakers. Yeah, that's it. That's exactly it. Craziness. All right, I think time's up. Thank you, Amy.
Woohoo.
Thank you, folks.
Oh, and then we want to peek at Pete's pH electrode, please. Oh, actually, maybe if it could come a little closer, then we can see. We can stow the temperature probe, and we're gonna just peek at Pete's pH electrode before we put it away. Did we get it? We were at 11C that whole time.
Oh, okay. When we're looking for animals, like after we take our Chimney kids, the next thing on the dive plans out looking animal samples. Is that going to be in this Chimney region necessarily, or no?
We're gonna slurp some worms for Nicole before we smash the chimney, and I think.
Be a little hot?
Yeah. The mussels and clams are going to be at least 20 meters away from here. So, what did I write down? Corey came in before and said hold off till the end on the mussels and clams. I forget the logic why, but that's what my notes say.
We're waiting until when?
The end.
The end of the entire dive?
End of the dive.
Even after GTS?
Porch out a little bit.
Yes. Yeah. Hold off until end.
That was unnecessary.
What was unnecessary? Uh-oh.
I looked down on the iris on the suit, just completely dark.
Uh-oh.
I'll do that.
We've lost a little bit of your wrapper.
That's all right. Oh boy. And now we'll do the hot water again.
This looks okay.
So after you put that away, yeah, we're at this, the rotated volume.
in the flip, or you want to?
No, I was hoping they'd be able to look at it on the end.
Yeah, as soon as he's done, I'll
I
have
wanted to grab it and point it at the camera.
Oh, super.
Gently grab that so we can flip it up a little at the bottom. Either grab it or just kind of like scoop it from behind. Just tilt it up.
You judge your nuts.
Sorry?
You judge your nuts.
Gotcha. It's a nice monkey face.
It's beautiful
That's what
nuts.
they're saying.
Yeah.
Really nice.
Man knows this monkey's face.
Alright. Thing of beauty. Alright. Oh, I still see it. Oh, the red light's flashing? It's live. Alright, onward.
Alright.
Hey, it looks
You didn't
shiny.
kill it.
Shiny and new.
Alright.
Stow it or do we need to begin?
Stow, please. Is that right, Amy?
Yeah, you're done.
Alright, I'm
You're
done.
We're done.
Cool. Thank you, friends.
Thank you.
If you can.
I was gonna try to stow this better, but it keeps falling.
It's gonna happen. It is what it is.
Yeah, think I'm happy.
Yeah. Trying to make
I
that
think
big
the
stable
reason we're
spot.
waiting is they weren't happy with the other locations and they want to spend some time looking around. Okay, I can finish the answer.
Well,
Yeah.
Jordan is over there.
Grab that, put it in there, and go over infinitely better. Grab the rope right underneath it. it's gonna fall off.
Leave it there till we need
go.
plow box.
Yeah, I mean, it's gonna go where it wants to go. I usually secure it to the back of the box, but something changed yesterday. I don't know what it was.
Right, fortunate. Where to next?
We're gonna get out the slurp. We're gonna slurp some of those red worms that were at the base of the chimney.
Just actually a slurp with that.
I wouldn't worry about it. Just so the hose is underneath the cable for the and so you have
Slurping some worms for me. What are we slurping on?
Nicole. Yeah.
the way I did.
The one she was describing that she dreams of, so it's very fancy. And it's like red and pink and orange and white and then it's stuff on it. I don't know if you can see that from here. We're just gonna get some red worms. I hope they're the right ones.
Sorry to be distracted, but I was just cheering it on.
Slid back a little bit and try and get us a bit closer.
Yeah, trying to grab you. It's nice luck his fist on that. It's gonna want to do that.
That's gonna fall off.
Oh,
no.
man down.
So, yeah.
You want me to do this now?
Can you push it through a little bit?
Through what?
Back towards right. If it's possible, get a little bit more of the tube on the backside, and then feed it into the tube that's laying there, and then grab that and kind of use it like that instead of on the handle. If that makes sense. Might not go anywhere, but
I think it's like the insert inside there.
Nice push forward.
I don't think they can try to like slide that into the tube and then just grab the actual tube itself, like the hose. You know what I'm saying?
Yeah, it doesn't really work. This was
I flip it around. It's gotta go on that way.
This is what your whole plan's gonna do.
Yeah, that's, I mean, if it's possible, that's why I was like, well, no, it's not gonna stay, but you can just get it in there and then grab onto it. You know what I'm saying? Yeah.
You just use the hose.
So I'll be able to do.
So I just toss that in rock spots, one or two.
I'll have to try to open all the way up. You must press the second time. It's good.
Yeah.
I don't know if it's got heat.
Possibly.
Bring that camera back.
Yeah.
Let's say. Look at it.
maintenance list on the actual hose, just in case that happens, and then at least you've got maintenance list to control that.
You're probably not gonna get closer.
I'll get that.
I'll hold right here while you get some.
Okay.
Are we trying to slurp?
Yeah, Nicole thought that the worm slurp would be better than.
Yeah. I don't think she wants to slurp here.
Oh,
Right?
she does.
Oh, on the chimney.
Yes.
Okay, yeah.
Yeah.
Sorry, just don't, she doesn't want to round the muscle anymore.
No,
Yeah.
those red worms.
Great.
Okay.
Yep.
Oops. Should I not zoom in yet?
I don't think that's close enough. There's no stump of that, so some delta. You would give us a little yeah, so it's like the bottom of here, I think, isn't it?
Little red things.
Yeah, that's what we want. All the red worms.
Do you want to shuffle over a little bit? So they're just within the reach from there.
I'll let us see if I can.
Actually, I think.
I'll shuffle over a little bit. I'll get it more favouring your side there.
You got plenty of space up there. Round and muscles.
There might be something next to me that I'm bottom against here. Yeah. There's something there. Yeah, is that overview enough for me? Alright, turn on the slurp.
Slurp.
Yeah. Still. What's that there? What? Sorry?
You're in jar one. Yeah, something's going in. See it? Up there.
Oh, I don't see anything going in. You see it?
In jar one. Up there.
Oh, there's some worms.
Yeah, not worms, but definitely flow.
Okay, cool.
This is the script right now. Awesome.
Well, we're gonna pick up the chimney and we might get some that way, but I think. I think, I don't know, it's starting to lift off.
Yeah, it's
Oh.
definitely coming. Wow. Readjust. You've got something in jar one anyway, it looks like a creature.
We got a creature?
I think so. You,
Oh yeah.
is that, or is that just
Oh yeah, that does look like
a creature
something in there.
shaped bit of mud?
I couldn't tell you. It's something.
It's something.
We have a couple of questions in the chat asking what the most common minerals are coming out of these vents. Could you explain that for us a little bit?
Oh, sure. Yeah, that's a fun question. So, as broad categories, there's a lot of metal sulfides, sulfates, and also some silicates that form in hydrothermal fluids. And in terms of which minerals specifically, the sulfates that are most common are anhydrite, which is a calcium sulfate. And it's kind of cool because it has retrograde solubility, which means that when you put it in cold fluid, it dissolves, which is the opposite of what you expect with most minerals. Barite is the other most common sulfate mineral, and it's the mineral that we use the Geiger counter shipboard for because it can be a little bit hot. The most common sulfide minerals that we end up with, so chalcopyrite, which is the copper iron disulfide, is often lining those interior sparkly walls of chimneys. Pyrrhotite, which is an iron sulfide. Think about here.
This bit.
Yeah. It's super common as a interior wall lining. We see both polymorphs of iron disulfide, pyrite, and marcasite. Marcasite forms at lower pHs. We also see a lot of sphalerite when you see the black, really poorly crystalline mineral. That's often sphalerite. What else? Yeah. Do you think we have worms in this jar?
It's definitely something.
Something.
I don't know if it's definitely.
Bring the camera out and look to the right.
Me.
Look to the right.
That's, and by right you mean left, or do you?
We changed it, remember?
I can't keep track.
All the way to the right.
Whee. Oh yeah, can we get any? Oh, I think
To the right, look at the jar.
that jar.
Oh.
Look at the jar.
Oh, I can use this camera to look in the jar? I had no idea it went that far over.
Turn that light off. Sorry. Bring your iris up, ISO up on your camera.
We're just checking right now to see
Keep going.
if we had captured any critters in our slip sample. Specifically those
Keep going.
red worms that we've been seeing.
And spin. You see in the background? So if you rotate it over to where the floor is,
Kill it first.
Oh, I think I see a couple floor worms from here.
yeah,
Yeah.
definitely
Right,
something
Alt index.
nice and easy. I turned it down when I turned it a little bit. Can't get it to go. Turn it away.
So it's full command.
There it goes. It's fine.
Okay.
Spin all the way around.
Well, this is much easier than looking in the black and white camera.
Two more. Alright, spin on that. There's a couple on the left side. You see pinkish red on the left.
There's a lot of guys swimming around in there.
Yeah, I see a lot of the, like, I definitely see the reddish coloring.
Yeah.
It's a couple of worms. Can we slurp for a few more minutes? See if we can increase that accumulation.
Yeah, so you want to go in a different jar.
Okay,
Well, we could go back to that jar if you like.
yeah. I think it's, since they're from the same place, if it's not a worry about losing them.
Yeah, let me index it back and then. One. Should be it. It's a black one.
We're going back for a couple of potentially more. Bless you. Have we found a radioactive rock sample yet?
We've found some gently hot rock samples, but nothing at a
I didn't know you
concerning
called them
number.
hot.
That's a relief.
What do you do if you find a super radioactive one?
I mean, if it's really radioactive, probably throw it back overboard.
Yeah.
But, luckily, we have not run into that. I mean, you can also cover it up. Basically, a lot of the radiation from these would be alpha radiation, which is big particles, and you can stop it with a sheet of paper. So if you
Okay.
put it in a covered container, you're in good shape.
Mm-hmm. Cool.
Yeah.
There's a slippery one.
Have you found any radioactive samples, like, on any other expeditions you may have been on?
Not that I've worried about.
Okay.
Yeah.
Cool.
Slurp 1. Section sampler 1. I guess is the formal name. Sorry. It's SS1.
And are all of these sections sampler? They're not all honeycomb, right? So like that's the sort of detail I would include in this map. Is that it's where it's wrinkle.
Yeah, well, it's very cool. I don't know if someone else wants that, but
But I guess my question is, are all section samplers that's good for a variety of people?
I don't know. Probably. I haven't. Yeah.
Good.
The only slurping I see on this side pan is the Nicole slurping. But doesn't mean it has to be that way.
See, we have a couple of new viewers in the chat. Welcome in. We're currently slurp sampling some worms, some hydrothermal vent worms. Oop.
How about on this? Can we reach this white patch? That's got a few wigglers on it. And maybe after that we'll give up and move on to the rocks. Because I bet we're going to get more worms on our rock crabs too.
We have a couple of follow-up questions about the radioactivity. What elements exactly are radioactive in barite?
So radium can substitute for the barium in barite. You can also have uranium precipitate at kind of low concentrations. But yeah, radium is the main element we think about.
Cool.
I saw a critter in there.
Wee! I'm wiggling this whole jam.
Zoomed in there, like right in this corner. If I zoom out,
Oh, come in down. Hey. Oh yeah, this situation.
yeah, look at this guy.
Can we get that creature?
Trying. I might have to.
Is that a worm?
What creature are we trying?
He's right at the edge
The
here. I'll
like
just try to
disco
show him across
dancing
a little
one.
bit.
Two more.
The one with the
See, it's
red.
right. All that flow.
I wish I knew more about worms for Nicole.
There's one there too.
I might be able to get in there. I'll just try to settle. Just do it. The camera's back. This guy.
Do you guys know anything about worms? And the red ones, that's about it.
That is red. Maybe that was like the one that came out of our rock the other day. It was really big.
It was fairly big, and there was that little bit of a dispute about whether it was a biter or not.
He says that they bite.
He says they bite.
I can try and come around more. I just don't know what's right next to it. There's something that's stopping it. The big rock right next to us that's kind of hindering us. Try and push forward a little bit. Just get around that. Push that rock over anyway.
What about up top here? There's a bunch of worms on this face. Is that a more accessible face? I don't know. Maybe we have enough worms. That'd be fine.
How many worms is there? How many does she want?
I don't know. We did a lot of them.
Well,
She said just get a bunch. Ooh. Oh, this one is pretty. How was it going to say that?
I don't know if we actually started slurping 25 minutes ago, but we maybe were just like getting the slurp out.
Okay.
Preparing 25 minutes ago.
25 minutes seems sufficient. Okay. After
Is
this,
I don't know. I guess we'll double check the log, but that's what I wrote in the summary though, which might be a little off.
Okay. Excellent slurping.
That's in. You got it.
Yes. I think
Right, indexing so he doesn't escape. Okay.
ooh, amazing.
Yeah, you also have that.
Nice.
I'm gonna come up just here. Clear myself because I did a little bit of spinning around there. Yeah. So, I'm out of that now,
I'm getting married this summer. I'm going to go visit Keith. And then we're going to geographic tours.
Okay. So,
It's just the postman.
do you want some rocks from him?
Yes, we're gonna try and pick up the chimney orifice that we took the IGTs from, which might be non-trivial to figure out right now. So we're just gonna try and take some orifice trim pieces from that chimney.
You want to try to use our mesh bag?
Sorry.
Do you want us to try to use our mesh bag for anything?
I don't know. This kind of fell over as a nice chunk, so I'm hoping it stays together more than it looks like it would. We already broke off the crumbly beehive, so I feel like the remaining bit is a little harder.
Okay, so we're one.
Dangling. Dangling in front of us.
The what?
This is dangling in front of the book.
I don't know.
We're gonna have to pick up some sulfite.
Oh yeah,
For the
wand.
sequence.
The wand's been on.
Yes, so this one's gonna be a lot of things. Because Rachel wants some of it in RNA later, and then Jill wants some that's not in RNA later. So
There it is.
So currently on objective 8 of the guide. We have to get rid of our 8 of
What's after 19 for the whole time?
We have 19 objectives in September.
Do we have a off bottom time?
I think Roxy said about 9 a.m. tomorrow, right? Maybe
Off
we're
bottom.
working all night. No, or maybe we're supposed to be on deck at 9 a.m. Says deck to deck. Deck to deck is 24 hours. And we went in at 9, so off bottom 7:30 then.
Okay. What's after active?
So we're gonna pick up that piece, which is gonna take a while because we need a biobox
Grab
piece.
time.
We need 4 RNA later pieces for Rachel.
Yeah. Is it no what size?
We're skipping this for now. We're gonna come back to that. And so I don't know. I hope Roxy's still or Corinna's still up. Oh my goodness. Corey said to put off the mussels and clams to the end, but that would also mean maybe putting off the super to the end, and they didn't speak directly to that.
Okay.
Yeah.
Is there other rocks that do you think I'm going to happen during my shift?
So at some point, yeah, so 14 is do some exploring for chimneys. Jill's decided she wants smoker 3, which is not what we want. We want flange from 5. And if we pass an active chimney, I'll take a snap opportunistically.
I can pass at any point if we're passing an active piece.
Yeah.
Okay.
And then, yeah, I think maybe I think we're swapping this and then coming back to the clam beds at the end.
Okay.
Yeah, I would take our flange and inactive above our push boards here.
Do any talus instead?
I mean, I always want talus, but we got a bunch of nice pieces last dive, so I think flange, inactive, talus in that order would be my
Our scientists are deciding what samples they want to do next. I saw a couple of comments in the chat a little bit earlier about crew rotation, and since I'm a crew member myself, I thought I'd answer this one for you while we get set up for our next bit of sampling here. Our crew normally does 2 to 3 month rotations, so myself and the other MMT will rotate every couple of months so that we can get some time off. Our ROV pilots are not so much on a regular schedule, and that the 2 to 3 month rotation also holds true for our other departments on the ship. Now, as for our schedule on a day-to-day basis, the technicians and ROV pilots work 12-hour days, which are staggered oftentimes. So we'll have a couple of technicians working the night, a couple of technicians working during the day. That way we can really help out the scientists doing 24-hour operations.
Do they have little...
And other departments on the ship, such as engine, deck, will also work 24 hours together, but might break it up in different ways.
5 to 10 more.
Okay.
But it's a pretty scraggly bunch.
Yeah. Is Corey still up here now?
I do not know.
Okay.
I
might go look for Roxy if she's
Yeah, it sounds pretty long on paper, but we try and break it up.
We're gonna pick up
For example, I'll try and break up my day a little bit.
Okay, so I'll
But there's usually so many interesting things going on that the days pass by very quickly. It's very easy to be so focused on the science and everything that we do here that weeks kind of just go by and you don't really notice.
it's a big shared ship.
And then you go home and you're like, wow.
Rachel wants 4 pieces in RNA later. Jill wants a piece who's paired with the IGTs. We'll take a little piece of the same piece as Jill's piece. So I think the idea is to take a big piece, do the 4 RNA laters, and then the remainder goes to a big chunk of the biobox wide later. I'm not sure about is the next step is
And our scientists, in terms of rotation, will rotate in and out on a per expedition basis. It's not really as regular. Although even now with the new ship Valcor 2, we do still have some returning scientists. For example, Nicole has returned on this cruise from our coral health diagnostics expedition in April. So we definitely have scientists and other folks coming back to continue answering their questions, researching more aspects of what they're interested in.
So that's the question. But if you want, I can go ask her and you can direct the Chimney.
You know the Chimney better than me, so why don't I go ask her?
Okay.
All right.
You want this?
Yeah. Thanks.
Thanks, Pete.
Yep.
But we're very lucky that we have a very interdisciplinary team of scientists. We've got scientists from Harvard University. We've got scientists from Lehigh University, Lamont-Doherty Earth Observatory, excuse me. We've got on board, we've got some folks from the Charles Darwin Foundation and Galapagos National Park that we are collaborating with. We've also, our chief scientist is from University of Rhode Island. So lots of institutions are really working together to paint a multifaceted, interdisciplinary picture of what hydrothermal vents look like. And yes, we do have Octo Odyssey Leg 2 coming up in December, so stay tuned for that. We can find more information on our website, schmidtocean.org. Go to the cruises page, and all that info is all there for you. I could also probably drop a link in the chat as well. All right, our scientists are moving along with their sampling.
Big chunk here, but I thought this was the way we came, but we did come off, so.
No, alright, so we were set up at
Could have been sitting there and pushed it this way.
315 was the thing we were sitting at, and then we came to our starboard.
Well, I thought we were sitting at 160.
Well, I thought this afternoon we went out to open this morning. When I did it, we were sitting at
Oh.
315. And then we got home to this.
You think this is it?
Not to over
Doesn't look that fresh.
So I'll guess, just by looking at that, it would be roughly north. Where would it have knocked over then? Generally, like right over there. We were facing this direction. Yeah, it almost over here, knocked it there.
We're just knocking over sideways.
Alright, got clarification from Roxy, so
Okay.
just FYI, so sample this, and we're going to go ahead and skip the animal stuff.
Okay.
I may fire the missiles above here, but that'll not be too worried about. Do you want to just do the stay on watch till you get your chimney collected, or do you want to turn it over to me? What do you prefer?
I'm happy to turn over to you. This is a low stakes chimney for me.
Okay, I'll do it if it's a low stakes chimney.
Although, yeah. Oh, I can hang out with you because what we're looking for is a chimney that we previously pushed down.
Oh, I see, okay. Would you mind keeping eyes on that? And I'm going to run up and put some sweatpants on, and I'll be right
Take
back.
your time.
Okay, thank you.
For sure.
This is like the 160, right?
Yeah, it would be somewhere.
Good. Trying to put our rock forward in the chat, but I was just asking that. Sure.
Yeah.
In our chat.
This is where we were.
This is where we were.
Top of this belt. So it should be over. This is exactly where we pushed
I
it.
was trying to, yeah.
Yeah.
Do you
Very
know
nice.
if
Run around
up?
to the far side, and it's not listens off. Just take the whole thing out.
The switch we got enough down earlier.
Should be
To have more, what's the one?
It doesn't look like there's something there. Unless it just turned into dust.
IGT 1 and 2.
So that's exactly. Yeah, the far side of this little
Okay, so this was exactly the item we were on when we were doing it. So it should be like this sort of area, the opposite side.
So this is what Chimney wants to do.
I'll look right down.
And what's the due on that? The heading was 360.
208, 208.
So that's where we were set up, and then we had to move, so we moved around closer to the 180 heading or so, and then got to the road like that.
Let me go back to the
So
time.
from 208 they do the Mount part. Yeah. And then you went from the left when you were at your 180
Well, it's to our starboard side.
to the starboard. How annoying would it be if it was still starboard and larboard?
That'll be nice.
Should be somewhere.
It was pretty
And it's,
black and ashy looking.
and it's hiding under these mussel mush.
I'm looking for a picture of it again, or two more of the picture.
Could it be this? That's a loose piece.
Possible.
The one on the right looks.
The one on the right.
Here, I'm trying to find
We were
it.
at 250.
Oh, look at that cutie. Oh, another one.
What are we looking for actually?
Piece of chimney.
Piece of
That we
chimney.
knocked over before.
Loosen with this.
I think if we can figure it out, we'll just take some fresh grabs from the same spot. Time to make a decision.
I'm digging the one.
Yeah, the west side, wouldn't it?
Because they took, I just
Right
used
now
two
we're on
after
the
they knocked it
southeast, I
down.
think that would be.
Or did they just?
Yeah, thanks so much for coming by. We really appreciate
I'm
all
not sure
tuning
where
in.
the IGT Yes, I think 2 was post
See
knockdown.
what I'm saying?
Oh, yeah.
Yeah, started like that, moved like that, knocked it over.
Happy to answer any of your
Because I think
questions.
they switched
Yeah, so it should be
orifices.
this one.
Yeah.
Can we poke at this thing on the right and see if it has a,
Sure.
if it looks fresh?
Just having a quick peek over here in case there's.
Is it rolled down the hill more?
Yeah. You want to poke it out.
If not, we'll just break a fresh bit. Whoa.
You want to see.
Yeah, that's a fresh break. Okay. So that's probably too big for the biobox.
Wow, bucks.
So we're gonna take 4 pieces and put it in RNA later, and then a big piece in the bio box.
On this piece that I just moved.
Yes. Yeah. Of course.
Sure.
But I think we just did a geometry on arrow for what we just switched. With RNA here. So,
Hello.
right there. So it's on 2 pages, but sulfide saline one.
For a while.
And then, so 4 RNA later quivers is there.
To open up the RNA later quivers, which one? Three.
Okay.
Alright, okay. Thank you, Amy.
Do we only have 3?
You're welcome.
Thank you, Amy.
Thanks, guys.
Thank you.
Hello, hello, hello.
What's up?
How are you all?
Can you explain that?
So, what are we doing?
We're going to get chunks
I'm-
of this and put in RNA later, but we only have 3 RNA later.
So, we're going to go find out what the whole RNA later story is, because I was also told that they don't want RNA later. So, in a few minutes, we'll have an answer
Okay.
on whether we do it or not. If the answer is yes, then we only do 3. Amy, do you know, is there an IGT taken from here?
Yes, this
Okay.
is the paired place.
Ah, okay, so,
Chimney
all right.
1 paired.
All right. Well, I'm going to wager that the answer is going to be yes. Anybody want to take a counter wager? No, no one wants to take that wager. Okay.
Yeah.
Yeah, so we'll find out in just a second.
Hi,
Hey.
I just need to amend something on
Sure.
the diet plan.
Yep.
So Jill had said, it says don't go to Chimney 3, and Jill actually does need 1 more IGT there because she had
Okay.
one of the samplers not work.
I see.
So-
Oh, yeah.
So I think she would like to go to Chimney 3 and get an IGT, and then you guys can double choose
I
the
see.
second Chimney for another
Oh,
one
here it
more
is.
IGT.
IGT, does that say sample 3? What is that?
No, I
Smoker
guess-
3?
Yeah, so that, okay, good. So somebody already
Okay.
put that in. She wants Smoker 3
Okay.
as the
Now,
IGT.
can I get your take on this, Roxy? Should we
Yeah.
do this first and then do this?
I think you and Jill can decide.
Okay, we'll decide that.
Yeah.
JC? Were you about to say something?
I was trying to zoom in on that for
Yeah.
Find a place around here you want to record.
I'm going to put
Okay.
it off.
Tell me what you like to do. Folks, can I take the camera?
Oh, yours?
Yeah.
All right. What do you want me to...
make an observation of the anhydrite and the paired types.
Oh, this is a rock thing. So the...
Just so you see the exposed chimney.
Right, I see, right there.
It's just visually.
Oh, someone changed the orientation of the camera controller. Cool.
That was very pretty. Oh, Phil, did you see that Maggie said she will sub in for you?
Oh.
Yeah.
The fluids are kind of in the way.
I asked her to.
Oh.
And because she won't get out
Here we go.
as early as you
Don't knock over the chimneys.
Okay.
That's pretty much number
I mean,
1.
you could have to watch her.
Rule number 1.
Yeah, that
Don't.
would be, that would be.
Okay, so I'll suggest she comes in around 10 then.
Can I see the model ROV? I haven't touched it. Can I touch it?
What, this?
Yeah.
You have to be a pilot to do it.
Oh.
You're welcome.
I have to be an ROV guy to do it.
That'd be weird, but ROV person. We're inclusive.
Oh, you didn't. Oh, you weren't there for the joke. Then. Somebody had asked me, so
All right,
when are you
come in wide.
becoming an ROV guy? I was like, well.
Not on my agenda.
Wow, that is a lot of limpets.
It's a cool pink thing.
The scale worms?
The one with the shelly.
Yeah, the little
Are
thing
those
down in the corner.
the commensals?
No, the commensals don't have scales. These are actually called, these are the scale worms, and they, I think these bite too. A whole bunch of these wormy things bite. I think these are the ones. Some of them bite harder than others, but let's see if I can zoom in on the, I don't think I can quite get down. Well, maybe I can. All right, here we go, zooming in.
So far, so good. Those the form.
Ooh, pretty.
Oh gosh.
Ah, sorry, my bad. I resume now. There it is. Wow.
Oh. Are those little bristles at the end of the worm just like a continuation of the segmentation, or is it a different part of the worm?
No, it's the first. It's segmented, but it's not. It doesn't have those plates, those armored plates. So if you were to flip it over, it looks like a polychaete, but those armored plates cover like 80%, and that's it.
Is that what we see inside the mussels?
No, those are also polychaetes, but those are called branchinoid polychaetes, and they live in the mussels. And sometimes we go to places where like 80 or 90 or almost 100% of the mussels have that worm living inside them. So, you know, you shuck the mussel like you would shuck any mussels, and there's this big red worm hiding under the gills. Did you all see that? Did we come by the lab and see the worms living inside?
No.
Oh yeah, they're super creepy.
Yeah, you should come by.
Yeah. I might actually show it on live one night if you guys don't mind.
No,
I feel like that'd be really cool.
Oh, wait, the Galapagos, is that a thing? Like we can show?
I think so, yeah.
Okay. Hi, Rachel. Sorry to wake you up.
It's fine. I don't know where this 4 RNA later coral quivers came from. We only have 3 RNA later coral quivers.
Yeah, so that's that. The second thing.
Also, only 1 coral quiver is fine.
Oh, okay, so 1. All right, so 1 coral quiver. This site, this sulfide we're about to collect, has an IGT, and we'll be collecting samples for mineralogy. Sound good? Okay.
Yep.
All right.
Is that the same? This is the same chimney we have been sampling multiple times, or is this a different one?
That is a question for Amy.
I think this is the same one that
Is
I
it?
want to use.
Okay, and it got knocked over.
We sampled it yesterday, we sampled it today, and then we knocked it over on purpose.
Oh, okay, great, to bring it up.
To get a better source.
Oh, I see. Okay, there it is.
Okay.
So you want one?
Sure. Yep. Because we did get one yesterday from this chimney, but
that was the smaller, baseball size?
Little piece,
okay,
yeah.
we'll get one more.
Okay.
All right, thank you, Rachel.
But we do need live sulfides.
And that is for sure too.
Okay.
Thanks. Good night, Rachel.
Good night.
All right, folks, let's proceed. All right, I'm gonna let you do the camera thing. It's with you.
Alright, so I need to go RNA letter let off. So she wants one.
Yep, one
large bit in a file box. And what else?
No, one large bit in the RNA layer quiver, like, well, you know, chunk in there, and then the rest of it goes in the bio box.
Okay, so just 2 different pieces.
Indeed.
One in the RNA.
Yep. Cool. Thank you.
Better than 4.
Right.
I mean, just look down a little bit more. Bring the camera back to this side a little bit. Yeah, it's back. It's good. It's good. Rotate. There you go. Now you can tell the bed.
Chris, sorry to interrupt. Do you think a scoop is something that would be useful?
Definitely for getting the entire large bit. If I could get a little piece off, I could scoop that, put it in, and then it's the larger.
Cool. Okay.
Pete, I've got so many questions tonight about this mussel bed. What's the mussel to clam ratio here? Is it mussels? Is it clams? Is it both?
Oh, my money's on mussels.
Mussels.
We've seen a lot of mussels. The clams live in cracks, and at other places, like on the East Pacific Rise, you have these chimneys kind of in a flatter area of basalts. So I kind of think of it like if you could take a walk at a hydrothermal vent, these are more like and if you think of the chimneys as trees, this is like walking through a field where you see, you know, a smattering of trees here and there. And that's what the EPR looks like. There's sort of a chimney and then a lot of basalt, and then the cracks around that have a bunch of clams. This site's different. This does not look like most EPR sites. It does look like some other vent sites, such as those in the South Pacific. And at these kinds of sites, you find a lot of mussels. It seems to have more habitat for them.
Cool.
Yeah.
Should I call the one who we have two rocks over two different places? Should I say rock 1, rock 2, even though?
How about we say rock 1A, rock 1B?
Rock 1A.
Do you like that idea?
Sure.
What convention do you guys use? Because I'll just follow that.
I think that makes sense since we're splitting it. I just think we're going to be splitting it again later, so I'll have to remember that we're splitting for B.
Yeah, that's a good point. And in fact, you should put that in the notes. So you should be like, I'm going to call this rock 1A. Like, make that an observation.
Yeah.
I'm going to call this 1A, 1B, and later on we'll try and remember to call it C, D, and so on.
Yeah, we will.
Cool.
When we split.
Brilliant. Thank you.
All right, so this is the situation.
Can we just put it in the...
You want to try to put this into a box?
Yeah, let's
and
go
break
right
it
into
off
the bio box.
there.
Exactly.
Look at that.
Whoa.
All right, so I'm going to need you to porch out for me. All right.
I like your description of this as a situation.
Yeah, this makes even more sense pulling it around.
This thing is like this is all the way out. Yeah, it's pretty big. So. Yeah. All right, now sit down for me. Come down. All right. So yeah. If you could take the port arm and just move those lids somewhere so that when they fall off, they don't fall to a place where it's really hard to get to. Yep. We're more interested in 6. So that's the one I have to make sure I put back on. 10 isn't going to stay on even no matter if I put it on or not. So it's not as important. But 6 to a safe place. Yeah. My thought was I would put something in 6 to put it back on there before I did 5 blocks. But that's
So, Sophia, you got any questions you want answered while our pilots here are getting this done?
I always have so many questions. We do have a couple of folks wondering about how these mussels would potentially taste, but I can't imagine they'd be great because of the toxic minerals coming out of the hydrothermal vents. What are your thoughts on that?
Right. So let me start with a disclaimer. Nobody should ever try this again. But there was a time where a number of us have tried different deep sea animals, including mussels. Many of my more senior advisors, who I sailed with as a graduate student, have definitely cooked the mussels, but in particular those in the Gulf of Mexico, have cooked them in a white wine sauce, and they say they're really good. I think I had just the smallest of small pieces of mussel and riftio, and they both tasted to me like burnt match heads. And that was the end of that. Oh yeah. I even tried putting it on a cracker and cream cheese, and nothing helped.
I'm surprised you thought a cracker and cream cheese was going to be the...
That was my go-to, Chris.
Yeah.
Well, surely it'll all be better.
I don't really know how to follow up to this. I'm really sorry.
So Dr. Curtis wins the conversation.
Yeah. And that's the end of our show tonight. Thank you. You all have a great night.
They used to do things differently.
They used to do that. By they, you mean me? Yes. Yeah. No, it's true.
Science has changed.
That's right.
Science is science.
Science has evolved.
Look at that, that's beautiful.
Yeah.
Oh, you have to kid me.
Just drop
I want to hold on to it so I can try to break that tip off. But the brain for
so heavy.
and then we're gonna have to fit her out to get it out of the box for us.
Orange present on one.
Ooh, we have a great question. What prevents the mussels from cooking where they are now?
That is a great question. A lot of us, myself included, have studied how hot the animals around vents can live. Biologists call that an animal's thermal tolerance. People have done this with microbes too. For a lot of the vent animals, we used to think when we first discovered them 40 some odd years ago that they could be, living at really high temperatures. Well, they can't. They're good at dealing with warm temperatures, like a sauna, like a hot tub. That's about the temperature around a lot of these animals, so in the kind of, 90 to 105 degree Fahrenheit range, or something like in the 25 to 30 range, and that's it. So their thermal tolerance has them living at those temperatures. If you look at if you've been watching our live stream, you'll see that the really hot water is in the 200s or 250s, and to our knowledge, nothing, not even the most thermotolerant microbes, live at those high temperatures. So to answer your question, they're not cooking because they're really good at living in sort of sauna temperatures. That's not true for all of the animals in the deep sea. These are particularly good at it, and their neighbors outside of vents wouldn't be able to do that.
Do you want a piece of this for her arm?
Yeah, Chris, that's what I was thinking. I was wondering if you could bust off.
I was going to try to get it in there and bust it off once I got it in, but
yeah. Well, as long as we get a piece of this in some way, shape, or form, doesn't matter which end or even which piece.
Can you bring the camera out a little bit? Not a little bit.
Is this going to be an issue for going back to
Is that enough? I'll start with this and I'll get
Start with that. Small moves, Chris.
I can practically smell that rock when it just went like that. I remember how they smelled on the Mid-Atlantic Ridge. They were very sulfury.
Yeah.
Yeah.
Okay, I'm going to call this RNA samples R1B.
Okay. Chris, I'm curious.
Oh.
Yeah, go ahead. Do you think the bio box is beefy enough that if you push down on that, it would break a large chunk off? Because we really should close this on the way up.
Yeah, I'm gonna try to maneuver it to get it going.
Understood. Understood. Okay. Trying to think if you could solve two problems with one break.
Turn it counterclockwise, it might slide in a little bit better.
All right.
Maybe.
All right. So if it goes in, do you think you'll be able to get a smaller piece from inside? Because it would be nice to get a good RNA later chunk.
I won't be able to get it completely in, so I should have some sticking out where I can use the arm and the box itself.
And one last,
break it off.
got it. One last question. If this whole thing falls in, is there anything left at the chimney to grab a piece off of that? See what I'm saying?
Yeah, there was.
Okay, great. So let's just focus on this and then we'll worry about
What coral cover did that piece go into?
it went into the, hang on, I'll
Number
give you,
6.
yes, thank you. Yeah, you got a few chunks, right?
A little bit there.
Yeah. There's another piece that broke off. You saw that, Sam?
Yeah,
Mike?
yeah.
Yeah.
It's right next to where you were.
Yep.
It's the dog to the side.
Does that make sense? So later there'll be a page.
Yeah. I think Mike and I saw a piece on the right-hand side.
Yeah, just a single bit. It's in the middle of the bio box window. You know what I mean?
Yep.
Right
Yep.
there.
That's good. I'll stop it.
There's it right next to it. So the lighter colour.
Yeah, exactly. Yep. There you go, Chris. Yeah, see that?
Yep.
Actually, all that pyrite is not part of us too.
There you go. Perfect.
Okay. After we pick this one up, we're gonna have a rule about how big our rock we can try there. Which, coming from me, is crazy, because usually there are no limits. More?
Yes, please. Let's keep going because you got some busted off pieces.
Yeah.
So you got a pretty good setup. Or, you know.
Right at the edge there, front right corner. Yeah. What's that?
Yep.
Not just two, but I called the one that went to ROA.
Great. Thank you for letting me know.
I usually go with the fracture right
The
there
later
next to where you are just now on the main rock, where
That's
where
fine.
that came from, kind of. You see in your sit with that like crack is, caught that little piece right there, I think it's a big fracture.
Nice.
It's fuzzy.
That's fine. It's definitely fuzzy.
Is the fuzzy stuff just filamentous bacteria or other microbes?
Probably filamentous bacteria, and those are just bacteria, as you and I have both studied, Sophia, that make long strings. And the white is probably sulfur. They take hydrogen sulfide, the rotten egg smelling gas. They take that out of the water because it's dissolved in the water, and then they make little deposits of elemental sulfurs, sometimes inside their cells, and that's like their storage, energy storage. So it gives them a white, creamy color.
Originally, to break this component and stuff. Oh no, was that one in? That's good.
Yeah, that is good. So Chris, at this point, I mean, we got a pretty good RNA later sample, so if you want to try to grab that highest most nub and just break it or bust it up, if you get a sample, great. If you don't, then the box looks like it'll seal better. What do you think?
Win-win.
All right.
It's gonna be a heavy rock.
Yeah. Sorry, Chris, before you do that, is that a chunk of this sample right in front of the bio box that you could
It
drop
is.
an RNA later?
It definitely is. Right now I need you to zoom in on that. That's it, yeah.
I'm zoomed in on the sit cam here. Got a nice chunk.
Now I just need it right on that. Right there. Yeah, so I got just a little bit of view. Perfect. Alright, can you try putting the port to the bio box down for me real fast? Yep. Make this a lot easier. Down. And then we'll see what we need to do as far as closing it all the way. Alright. Blasting up the chunk.
Stop.
Yeah, that's not good. It does.
Awesome. What, can we go ahead and put the lid on that and then call it a wrap?
All right.
Did you try to bring the firebox lid all the way down, or you just stopped in advance?
I think stop on something.
It's hitting something. Yeah. Got it.
Drop down there. You get a little mess with it. Caught on, dude.
Is that sealed up?
No.
Yeah, I didn't think so.
Caught on something.
Yeah.
I think you just maybe moved it like it was just rolled to the handle.
Good to go.
Nice.
All right, now if you want to open that back up, I'll see if I can get this rock to go down a little bit more.
All right. Yeah.
Open it. Bring your camera back up. There you go. Look down for me. Whoa. Peter, did you ever make it over to Spain while we were there?
No, I wish I had.
We had quite the meet and greet going on.
No, I know. I just couldn't do it. I had some teaching or some other obligation.
Get you with your priorities.
What's that?
Look at you with your priorities. Can I try that? Down.
Are you being rude to our guest?
Nice and tight, or no? I can't
Are
tell.
you being rude to our guest?
No. So that's pretty good seal, I think, first.
Is it a good seal?
Yeah.
Okay. You sure?
I'm gonna try to push down this corner, see what it does.
Let's do that. It just looks cattywampus to me, but I'm not sure.
It's down.
Yeah?
Yeah.
Okay. Cool.
All right.
All right. So let's move on. At some point, Chris, I may ask you to poke at the other corner because this sample does need to come up cold. But we can move on. Let's see.
Okay. If I look at it with the net cam.
Mm-hmm.
Can't really tell.
Yeah.
It looks like it's down. I can't really see it. I can push.
Let's just give it another. Let's give it a push then on the left, and it,
Yeah.
if it doesn't deflect a whole bunch, then it's probably sealed, right? Yeah, Chris, I think you're right. I think it's down. All right, thank you so much for checking. That's cool. All right, so we're gonna, let me see, let me take a quick look here. So to give you all a heads up, so one of the things we're gonna do is we're gonna go exploring a little bit, go to Chimney 1, 2, 4, and 5. And we're looking for inactive chimneys and coring locations for Amy. So if we see anything like that, folks, let's just shout it out and we can drop a marker.
Okay.
Then at some point we need to get back to Smoker 3 and take an IGT. Now, I don't know where all these are. How close are we to 3 and?
So Smoker 1 and 2 are off to our northeast.
Yeah.
And then Smoker 3 is more directly north. We're looking at 125 meters to 1 and 2.
Yeah.
110, 112 to 3, and they're about maybe 50 meters from each other.
Roger that. So, I don't know. Let's, all right, let's go to, and you said, which one's close to 3? Is it 2?
1 and 2 are next to one another, and then 3 is off.
Let's go to 1 and 2, and then we'll go to 3.
Okay.
Thank you much.
Alright, so I will get the vessel moving in that direction.
We have Amy's pirate list.
Fortune.
Cool.
Oh, that's a nice eel trout.
I was thinking. Here's your ROV. I have a new waypoint for you.
RV Bridge, thank you very much.
Hello, Ollie. How are you?
Good, thank you. How are you?
Not bad.
Fantastic.
They're behind us. What? They are to the northeast. So, go right. Yeah. That's north. That's east. Right. To the 2 o'clock. Okay.
And that's
All
Tyler.
right. Cool. Thanks, guys. So, Sophia, what do you think? Is this a good time for people to send questions in if they have them?
Absolutely.
All right.
I'm gonna keep an eye on your.
All right, folks. If you got questions, send them our way. We're in transit on this. This is dive number. What dive are we on?
We are on 564.
564. We're on dive number 564, and we're moving from the site where we've done some sampling for geology, geochemistry, and biology, and we're going to go on a bit of a chimney tour. So we're checking out chimneys 1 and 2. We've got another chimney. Wait, where'd my list go? Here we go. 1, 2, 4, and 5. And then we're going to work our way to Chimney 3 and get a sample that we didn't quite get last time. We're looking at clams now. These are the Calyptogena clams. Actually, they have a new name. I think it's Turneroconcha. But they live in the cracks like this because they need hydrogen sulfide for their symbionts, but they don't get it from their gills the way Riftia does. That's Riftia's the tube worm's big red fuzzy plume. Instead, they stick this really warty, nasty looking foot deep into the crack, and they're looking for sulfur down there, and they take it up through their foot, and then they use their gills to take up oxygen, and they bring those two together again in the gills to feed their symbionts. And their symbionts take the sulfide and oxygen, they harness the energy from that chemical reaction, and they make sugars to feed the clam.
I personally have a question about the mussels.
Yep.
So we see different densities of them at different locations. I guess that goes for a more global scale as well.
Yep.
What sort of dictates that distribution of populations?
Yeah, no, that's a cool question, Sophia, because we know most of the answer to that, but not all of it. So going back to the East Pacific Rise, which is probably the best studied vent site in the world. When you go to a chimney there, again, they don't look quite as dramatic as this, but you see a bunch of tube worms called Tevnia when that chimney is first born. Say after an eruption and a new chimney is formed, you know, these tube worms come in and they grow fast, and then eventually Riftia, a different tube worm, settles and takes over in a kind of succession. Right? Anybody who's tilled a field or something knows that you have some plants that start and then other plants come in and then other plants come in after that. It's true at a vent as well. So tube worms generally end up there first, and then as the vent matures and the chemistry changes a bit and kind of gets a little slower and there's not as much sulfide, the tube worms are outcompeted by the mussels. Because the mussels can use the sulfide, but we think they also filter feed a little bit. So they seem to have an advantage of living in areas where the flow is a little bit slower. So whenever you see a big mussel bed, it's a kind of a hint that the conditions there are really good for them and probably not so good for tube worms. And then the clams have their own weird thing going because they use that warty foot of theirs to get sulfide from cracks, which neither Riftia nor the mussels can do.
So what you're saying is they all kind of have their own style of living in all the different little nooks and crannies of this environment?
Right, which is another way of saying it is they have their own niche or niche. And I don't know which pronunciation is right. So if anybody out there has a clue, please let me know. So a lot of these clams, these are clam shells. We're not seeing a bunch of live clams, although I did just see a few. And that just means that the diffuse flow in that site that feeds the clams has ended, and so has the habitat for the clams.
Ooh, have any sort of fossilized clamshells been found around vent sites all across the Pacific?
That is a good question. I don't know, because I'm not always sure how to define fossilized. That's really not something I think a lot about. A bunch of mussel shells are found with other animals living on them. I can also tell you that we have found mussels and clams and tube worms encased in lava, as well as ocean instruments we've left on the seafloor after eruptions at the East Pacific Rise. So if you're interested in this, you can poke around the web and look for hydrothermal vent eruption seismometer, and you should find a picture of this earthquake detector encased in lava.
I'm Googling it right now. What was that? Earthquake detector.
Yeah, it's pretty crazy. It was totally bananas, and it's also a bad day for the owners of the equipment.
Yeah.
They're not cheap.
It was a seismometer.
Yeah, it was an ocean bottom seismometer, and a big, you know, they put them in these round glass balls that are pressure vessels, because glass does really pretty well when you squeeze it, and so people make pressure vessels out of glass. Then they encase that in plastic, because you don't want to nick the glass, because then it will implode. And then you put this hard hat looking thing on the seafloor, and they came back and it was, you know, entombed.
I bet there are lots of shelves in lava.
Yeah, I bet you're right. I totally bet you're right.
Different than we've done sedimentary rock, but
Yep.
still awesome.
On the last cruise, they were, the scientists were interested in looking for two worms, larvae possibly living under the rocks. And two members of our lab team were out there along with my colleague, Dr. Monica Bright, she was the chief scientist. And, you know, we wrote this proposal pre-pandemic, and it sort of took this long to get everything organized and get past the pandemic. So they go out, they build all these widgets to try and figure out our larvae coming from the underground, and it's hard to do. It's a big technical challenge. But interestingly, I believe it was one of the pilots who said, why don't we just take a crowbar down and try and pry a piece of basalt up, kind of like you'd flip a paver over in your backyard. And sure enough, when they did that, they found little tube worms and a bunch of stuff crawling underneath there. So that was a pretty exciting moment for us. And I brought it, this came to mind because as we're flying over this basalt, you can see all these cracks and sort of little tiny caves and things. And I always wonder kind of what's living in there, because we can't just easily take a peek with a vehicle like this, or any vehicle really.
I direct any lasers.
You're on?
Oh, they are on?
Yeah.
Yeah.
It's hard to see.
Oh, sorry. Okay.
Don't be sorry. Interrupt whenever you need to interrupt for science.
Roxanna just
Yeah, they're on. Oh, hey, Jill. How are you? Oh, we're doing great. So, real heads up. So at this point, they got a big chunk of sulfide from I think you took an IGT at that orifice.
Yes.
Right, so they put that sulfide in there. I think that's awesome. That makes a bunch of sulfides people's needs, checks a bunch of boxes. We're doing this now. And then when you're ready, you tell me when you go out and go Smoker 3.
Okay.
Because if you want to prioritize that, just prioritize that.
Okay.
So I think we should follow your IGT schedule.
What I want to do is get one from one of these places.
Yep.
So this is great. This is exactly what I want to do first.
Yep.
And then I want to go get one over here.
Yep. Okay. So how can I help you make a decision about these? Should I call you in every time we're at each one?
No, I'll just hang out.
You want to hang
That's
out?
what we're
Okay.
doing now, right?
Yeah, that's what we're doing right now.
Yeah, yeah.
So we're going to 1 and 2 first.
Okay.
All right, cool. Thank you.
You can use it.
Pause on fluids.
I mean, you can like keep it. You
Yeah.
can
You
freeze.
share? Okay.
I mean, I'm not writing much right now.
I understand. I understand. So folks, if you're listening in, that was our co-chief scientist, Dr. Jill McDermott, who's leading a fluid sampling program, and she taught me on this cruise that that this is the first time people have sampled any of these fluids, which is astonishing to me because I learned that these were some of the among the first vents discovered, and it just goes to show you kind of how hard this is, and sometimes how when we make a new discovery, we get excited about a whole bunch of stuff, and sometimes have to come back and make sure that we get all the samples we need.
Is this Smoker 1?
So are we at Smoker 1?
Yeah.
Okay.
We're a little bit, according to the map, we're a touch southwest of it, but it is the closest smoker on the map to where our location is.
Where are we with respect to Smoker 3?
Smoker 3.
I think you said about 50 meters?
50 to 70 feet is right
So
here.
Smoker 3 is up that scar.
Yeah. So, yeah.
And we are at Smoker 1?
Yeah, we're down in here. So maybe 75.
Cool. All right. Can I take over SciCam?
Okay.
Thank you.
I saw a squid go around the horizon.
Rock what?
No.
How tall is
All
this?
right. I am tilting up.
I did see some black smoke to the left.
All right.
Came up.
Okay, I'm gonna pan to the left.
Just the black smoke coming up.
And I'm gonna zoom in.
Yeah, it was on the left side.
There was, yeah, it's a little further left.
Crab.
There was a small
Are you gonna comfortable flying this or you gonna hang on? What's that? Said if you want to get a
So this is pretty cool, Jill. At least cool from a biology point of view. It seems like it has a bunch of little openings along these flanges and the like. This is wild. Huh. All right, I'm gonna come.
Changing.
No, it's all good. I'm gonna come wide with the camera.
Yep. I'm gonna go back to the left.
Pan to the left. Okay, panning to the left. Chris, I'll center it up and then leave it to you.
All right.
It's all yours.
I'd be interested, and also the viewers are also interested about how we're sampling vent fluids and specifically how we're preserving that, because I can imagine that sampling 300 degrees Celsius fluid is pretty difficult. Could you tell us a little bit more about how that's done?
Definitely some stuff behind us as well.
Yeah, sure. Yeah, oh, there we go. That's the one I was interested in. Could we take a good look at that and look at how we would set up on it? I'm interested in the most robust flow that's closest to the seafloor.
Okay.
And I can talk a little about how we sample for vent fluids. So, like,
There's a microphone right there too, if it makes it easier.
Okay.
Oh.
Yeah, so as Dr. Gerges was explaining, my name's Dr. Jill McDermott. I'm the co-chief scientist on the cruise, and I work at Lehigh University, where I'm an associate professor. I study vent fluid chemistry, and the samplers that we're using on this expedition collect water at high pressure. When they seal in the fluid at the pressure at the seafloor. And at this site, that's roughly 250 times the pressure that we're all feeling here at the atmosphere. And so, but the fluids do cool. They don't stay as hot as they were when we sample them. These black smokers usually exceed temperatures of 300 degrees Celsius. And so the ambient water in this environment is more like 2 or 3 degrees Celsius, which is a huge difference. When we take a fluid sample, the fluid is chilled and quenched down to 2 to 3 degrees, but it holds pressure. And so what we then do is the vehicle ascends to the surface, or we can send them back up on one of our landers. And when the sample's back up at the surface, it's kind of like a can of soda. It's all contained inside, and it will not depressurize until we open it. So what we'll then do is we rinse the sampler off with fresh water, and then we take it over into the main lab here, where we've set up a high pressure pump. What we do is we use the pump to hook it up to the sampler, keep the sampler at high pressure, and then slowly take little pieces of water out of the sampler. And I do that using gas-tight syringes so that the gas doesn't escape from the sampler. And that can go straight onto a scientific instrument called a gas chromatograph. And I use the gas chromatograph to measure dissolved gas content. Specifically, what we're doing at sea here on the Falcor 2 is we're measuring hydrogen and methane gas. And the reason we do that at sea is it provides us important context for what we're collecting. And hydrogen and methane are two very important gases that sustain these ecosystems. They can both drive microbial production, and the microbes are the base of the ecosystem that all of the other animals rely upon. So hydrogen and methane are key to that story.
That's really cool. Are there specific situations where there'd be more hydrogen or more methane?
Sure, yeah. So the amount of hydrogen and methane depend on several factors. One is the type of rock that the water is interacting with. All of these events start off as seawater originally, and that seawater is circulating through the crust and circulation cells. As the seawater percolates downward through cracks, it is progressively heated hotter and hotter. And as it heats, it becomes chemically reactive. And as it reacts with the minerals that are present in the seafloor, that can increase the amount of hydrogen and methane in the fluid. And the amount that those increase to some degree depends on the rock itself. It also can depend on the temperature that the fluid reaches. And that temperature depends on depth. And this is analogous to the boiling point of water that we experience when we cook. So if you're a cook living in a high elevation place, you'll know that you have to cook food for longer, and that's because the boiling point of water is less hot at higher elevation. The same is true at the seafloor, where the boiling point of water changes where we have greater pressure. In other words, the deeper you are, the hotter the water can be.
Cool.
So the hotter the water can be, the greater the amount of hydrogen you can build up.
Mm-hmm. Gotcha. Have there been any sort of cool data trends so far? We have some viewers asking about that for any of the stuff you sampled so far.
Yeah, so far I've been working on my hydrogen and methane data. I can tell you so far that we're seeing some variation across the different types of fluids that we've been sampling over these first 3 dives. For example, if you were watching today's dive, we spent a lot of time at a clear fluid that we were calling the Chimney site. And that Chimney has about 4 times the hydrogen that the black smokers have. To me, that's very interesting because hydrogen is a great fuel for microbes. And what was also very clear at the Chimney site is that it hosted the most productive ecosystem that we've seen so far. It had the most abundant life. And perhaps that hydrogen is providing some of that fuel. In addition, the waters are clear, which to me as a chemist indicates that they're relatively low in the metal iron, whereas these black smoky fluids like we're looking at right now are really high in iron. And that's actively precipitating as iron sulfide, tiny iron sulfide particles, which gives it this smoky look. And so in combination, the higher hydrogen and the lower iron apparently are making that particular place where we were working earlier, the Chimney site, a lot more productive in terms of animal colonization, whereas these smokers are less colonized by those large animals.
So there were several chimney spots, but there's some that are the hottest of coming out of that area. Sketchy. I got a 2 turn out. This area is a little more open.
I'm sorry, say again?
Could you just fill me in on how to coordinate? I know we're heading towards Chimney too.
Yeah, so we were setting up. Yeah, sorry, I lost some time. So we were setting up to take an IGT actually. Pilots are looking for open orifice that visualize.
Okay.
Thanks.
Do you know which IGTs?
That's a good question.
If we take
This is an interesting chimney, partly because it's the furthest away
Oh,
from
okay.
our other
Yeah, yeah.
smoker, and it's deeper, right?
Yeah,
Where
sure.
it's a terrain area.
Yeah.
The animals always
That's a good point.
north of
Right.
fault, small fault.
Yeah, I see exactly what you mean. Yeah. Yeah, yeah, yeah. Yeah, and so like that little bit right there, right?
Yeah.
Yeah. Yeah, I mean, this just chimney looks. I mean, look, you can see how much white it has, and when we were zooming in, it looks like there's these. I don't know how else to describe it, but like sort of diffusers along the whole length of it. But I don't know how that works.
Yeah, I love these ones that have such high contrast.
This is the lowest one of the bottom right here.
This is the lowest at the bottom.
That I found.
This looks like a great candidate.
Okay.
It's like good place to set up for you.
Can you figure that one out? Yeah, it should be alright.
Is that active? Is that of use to you, Jill?
Is it smoking?
Come down and get a look at it.
Let's take a look at that.
It's this stuff right there. So that looks like a beehive.
It does look like a beehive.
There's another one.
I definitely see some flow coming from the back side of it there.
Sometimes if you poke those, they turn.
Right. And then this is something that's a little smokier.
Yeah.
It's set up and we can start poking around. Do we need to start low? See what we can do?
Yeah.
Alright, there's a rock right below here, so let me assess.
Yeah, I see what you're saying. Okay.
One up at the top. Yeah, sometimes it's. You sometimes want to go for the blackest.
You talking about this one? Yeah.
But that sometimes means there's mixed with seawater.
Oh, I see.
You see
Yeah.
what I mean?
Yeah, I see. Totally see. Yeah, of course. Yeah, that makes sense.
It's kind of it's an instinctual thing.
Yeah.
Oh, the blackest one.
Right. Right.
And it might not be the best choice.
Right. I mean, this looks interesting. I mean, I don't know. Those two low ones.
Those two low beehives, I bet if you reduce the beehive
Yep.
on it, you'll get a nice bird.
Chris, are you flying from science camp?
No.
Would you mind if I zoomed in for a moment?
That's all yours.
All right, thank you. And so, folks, we were JC, who works at the USGS, is on watch tonight, and she was asking about little red things sticking out of the rocks, and she was seeing these. These are alvanella worms. They're nicknamed Pompeii worms because they live on these really, really hot surfaces. And later on, when we're not so busy, I can tell you a little bit about a big scientific debate that erupted from these. But you know, they form these these tubes and live in these colonies. And the big question, and we still haven't answered, is just how hot can they go? What's their absolute thermal limit? I'm really interested in these little red worms too, and I don't know who they are. That's not my kind of gig, but I'm curious to learn who they are because they are all over the hot beehives as well.
Nice pun.
Mmm. Yep. Little one down here? Yeah. Pick which one you want. You want to start from left to right? All right. Yeah, nice little alvanella. It is someone's house. I'm just kind of looking down low. And that looks like, you see where the lasers are? Right above the lasers? It looks like it's right there.
That looks like the joint.
Yeah.
Where the beehive starts.
Yeah.
Yeah.
I think
That's where you want to sample from?
Might be a little challenging. Let's see, how much?
I thought about that. Is that beat up lower in there, so it's rock.
right? But if we come up to this one,
So higher up.
so that's the little sort of joint to the chimney there, right? Yeah, and then this one, let me just zoom in for you. And so that's about 10 centimeters across.
It's 10 centimeters
Yeah, because of the lasers. Yeah, it's about that. Yeah. So I think that I think that's cyanogrea, but I'm not sure. And I mentioned before that those are the mean ones.
There's a little small one.
Right. And then there's this one.
Then we have a small one.
And there's one down low.
In the bust, but small.
Yeah. So again, going with the lasers, the base is you know, under 10.
Yeah.
Just a little smaller. And then you got these wispy things down here, which I imagine aren't what you want, Jill. So I'll come wide with the camera.
Okay.
Whoops.
So that's how you feel. Do you want to go higher up on the chimney?
Which, like, if we were to go here or here, I think it wouldn't be a problem at all.
Okay.
I can bring us in closer. I set us up as far away as we could so we get a broader look.
Yeah.
But I can bring us in.
Okay.
We should be able to reach without much problem.
I'd be interested in just knocking over one of those middle beehives or both of them.
All right, so the one right where the crab is.
Yeah.
All right.
But I'm not going to commit until we see
All right.
how vigorous it is after we do it. I like that small one, but that might be a harder sample
Get
to
the
take.
left hook of beehive.
Because it's
Sometimes dreams do come.
I can bring
I
in a
knocked
little-
over one beehive already today.
Yep.
And that was a really good decision.
Yeah. On some of the other vents that we've worked at,
I'm sorry about that. I thought you were the other one.
we've
Sorry.
accidentally knocked over beehives, only to come back a few days later and they were back again with all their critters. So I get the feeling that they grow fast.
I think
So you're
I
saying
have
they
done
can
that.
grow after like a day?
Yeah.
Oh.
And they'll be
See
big
like
again.
the orange collar kind of
Yeah.
thing?
You'll die
You
one
want to
day.
do there or
knock it over,
below it where it
and
sort of
it'll
looks
come
like it
back.
joins? Yeah. What do you want to knock off?
Jill, you want to pick this or that?
That, the lower one.
All right, so the lower it is.
Towards the ROV?
Whatever you think is going to give you the most satisfying spot.
Top down like that, so much. I'll probably push it this way so you don't disturb the other one.
Right, you in the sick camera. So I can bring you in a little bit now.
Only if we're gonna take this one. When we commit.
Okay.
Ooh, solid, huh?
Is it?
With ROV, so yeah.
It's moving the ROV.
Yeah.
Let me go up higher there where the black is. Try it.
Think you can get her enough?
This, yeah, I think you guys can reach.
Well, then, as we're moving the ROV, you can tap it off.
It might be a little softer up top.
Alright.
That one's
Yeah.
soft.
That one's soft. You see how that one just.
But that's any objection if I zoom in with SciCam? Okay, zooming in. There's your flow, Jill. So that is, could I have, are the lasers on? Could I have lasers? Oh, there they are. They're on. Okay. So you're looking at about, I don't know, an inch, 2 centimeters, 3 centimeters. Okay, coming wide with the camera. A lot of crumbs, which we've discussed before.
I'm nervous about digging into it and training.
What about this one, Jill?
Should we try that one? I noticed it seemed to crack when you tapped it.
Yeah, like definitely you can see that crack right there.
It cracked right there.
Right where the lasers are. Oh, a little bit down.
Yeah, right there. So do you see where the lasers are?
Yes.
Do you think you could see if you could break the top off where that crack is? I think it had naturally cracked. Yeah. Because I think that's more solid, and so the you're probably first.
Folks, if you're tuning in, we are on the Schmidt Ocean Institute's Falcor 2. My name is Pete Gerges. I'm a participant in this cruise. I'm on the faculty at Harvard University. I'm a deep sea hydrothermal vent biologist, and I have been invited by my colleagues, Dr. Jill McDermott and Dr. Roxanne Beinert, to join them on this expedition. Right now we're setting up to take a high temperature sample, which means trying to find a good place to take a fluid sample without causing problems for the fluid sampler. After 40 years of hydrothermal vent research, there have not been fluid samples taken in the Western Galapagos. So Dr. McDermott and her team are doing a really cool job of generating some of the first data from these sites. And it's really cool to compare what we find here with those on the East Pacific Rise, which is easily the best studied hydrothermal vent sites in the world. So it's really cool, really exciting. We'll learn a lot about what vents in this part of the world, what they're emitting. And I, as a biologist, am always eager to learn from my chemistry colleagues like Dr. McDermott and my geology colleagues like Dr. Gartman about how the chemistry and geology changes. And I like to think about what that means for the life forms, microbes and animals found at vents. So right now we're just setting up to see if we can take a good sample with these gas tight samplers that Dr. McDermott was just talking about a few minutes ago.
Every time. Come on, Chris. I hit the button once. I say, wow.
Is that called black balance?
Yeah. Sick camera doesn't want to play my games. That's gonna be the sensitive science. Science.
You happy with that?
Huh?
You happy with that position?
Yeah, that looks good. I'm not sure that this one's been. Sometimes they look like they're not.
Yep.
Crabs like really did.
Yeah. Come on. Clean that top up. You want to see what it looks like.
Let's see that.
Let's see what's chest.
See if it's venting before being chill. What was that? Sam was saying something about the
Yeah. All right, I'll answer.
I get to go up when I want.
Can you answer?
The last one? No.
No.
I just need to see something real fast. Okay. I just want to make sure that there wasn't anything that I didn't notice on the first side like that. Yeah. Alright.
That's what Sam wanted us to do.
Yeah, she was worried that that there was a missed order of operations, but it seems to me that we should do the super after we get an IGT. If we don't get an IGT, why don't we wait and do a super later with an IGT?
I think we do. I'm not sure how many supers is it? Is it just one super or is it the rising groups?
That's a good question. Let's see. So once Jill determines IGT location, take super samples. 2 of them, it looks like.
Okay. Well.
But that says smoker 3. So I guess the confusion is, do we want supers at, maybe Roxy doesn't know that this is smoker 1. Let me tell her.
Yeah, see, she wants supers at both smoker 1 and smoker 3.
Yeah.
Because we'll go to smoker 3.
Yeah.
The second, or sorry, the 4th IGT.
Got it.
But I'm interested in smoker 1 for IGT 3. So ask her how many supers.
Roger that.
That's a nice worm.
That's a really nice worm. 2 worms. Like a one.
Polychaete? Question mark?
You're not a chemist. I think they're polychaetes, yeah. Those are some of the worms that Nicole studies. Yeah. That flow looks very good.
Do you want to try to poke it in a bit more and clear off crumbs?
Yeah.
Another option is,
Yeah, come above
guys, do you have a reverse flow on the suction sampler?
No, we do not.
Okay.
That's good.
Well, now that is a jiggy worm.
That was a nice flow too. He's dancing.
That is, yeah.
That's great.
What are your thoughts? What do you think?
Looks like a nice fluid.
All right. I think what we're going to do is I'm just going to put, if I can take over SciCam and just look at these critters here, and then we'll kind of let things settle out and see if we can take an IGT at one of these smokers down here. So, does that work for you guys?
Yeah.
Thank you much.
It looks like there's more of those Pompeii worms.
I'm going to iris down a bit. Yeah, so I guess now's a good time to tell you the Pompeii worm story.
Yeah, I was gonna say, could you tell me about the debate that you were talking about earlier?
Right, absolutely. So it was so I was in graduate school. It was around 1998, and a colleague working with a different vehicle, the Alvin submersible, was taking temperature probes to poke around the Alvinella worms. Right, he was really interested in understanding their thermotolerance, and by thermotolerance we mean what's their temperature, how hot can they live at. And so holding a temperature probe with the Alvin, and this probe is I don't know, let's call it about a yard long or a meter long, and it's about the stiffness of, you know, like a kind of car antenna, maybe a little stiffer.
Okay.
And so he was poking at it and put this probe into one of the Alvinella wormholes, and a worm crawled out and was spinning around the probe, and the probe was reading 81 degrees Celsius. Someone mind looking up 81 degrees Celsius in Fahrenheit?
I got you.
How mu-
162 minus 16, so 178. I would have gotten there. So.
I know, but math show-offs. But I think the so yeah, so it was north of a, what, 150, right? Something like that. And then published this paper on it and said, I have data showing that these Pompeii worms, these Alvanella worms, live at 100 and whatever, at 81 degrees Celsius. Now, some very excellent French scientists have been studying these worms since their discovery in the early 1980s, and they called foul. They're like, absolutely not. That doesn't make any sense. And part of their reasoning for being so quick to say this doesn't make sense is that previous studies of animal thermal tolerance in the desert, these things called desert fire ants in particular, show that a lot of animals are really living at temperatures of about 65 degrees Celsius, and that's it. That seems to be this upper temperature limit. And so they were saying, no, this doesn't make sense. So they went back to the labs and they started doing some cool experiments. Like, let's take Alvanella worms, let's take their tissues and see in pressure vessels at high temperature when they fall apart. And basically all the components that make up an Alvanella fall apart at pressures and temperatures that are like in situ pressures, the pressures we see here, and temperatures in the 60s. So lots of research went into showing that biochemically these things probably don't live at 81 degrees C. So it turned into this pretty big debate. The cousins of these Alvanella worms are called Paralvanella, and they live on vents off the coast of Washington and Canada. And in 2006, I had the opportunity to study those worms, and my colleague Dr. Ray Lee and I decided, well, let's put them in an aquarium, a high-pressure aquarium, and put a temperature gradient in there. And let's give them a choice of where they want to go. And what we found is most of them chose to sit between 50 and 60, but a number of them made excursions, like they crawled to the hot end of the aquarium for 5 or 10 minutes, where they were there at about 70 to 75.
Wow.
And then they crawled back. And that reminded me, like, oh, you know what? A lot of creatures do that. They go somewhere really hot. Like, I love sitting in a hot tub. A lot of us do. But you couldn't live in there. Like, your body would have a really hard time thermoregulating, right? So I think the answer is that a lot of these animals live at, these Alvanella worms, these Pompeii worms, they live at pretty hot temperatures. It's not any hotter than any other animals studied, we don't think anyway, but they're taking little trips into really hot water because maybe they can actually graze on microbes and the like. So yeah, that's the story. Dr. Jill, what do you think?
Now, can we take a look at the chimney?
To the left?
To the left.
All right, I'll take the science cam, zoom in wide.
That's
I mean, there's like a little flow, yeah, that,
There's like a little source over there.
yeah.
It's too small to see.
Does also being mindful of time, do you think, Jill, are you interested in having him take a scoop and trying to clear this off? Would that be useful? Kind of sweep away the little nuggets?
Sure.
Do you all have a scoop handy?
You do.
All right, come on wide. To the right. This one down here, or which one? Yeah.
I just want to see if that is kind of naturally through the orifice.
Actually, that's a good point, and or we could use a scoop there.
Yeah, the longer it settles out, it sometimes takes care of itself.
Yeah, fair enough.
It looks a little more. This one looks a little.
Yeah. Yeah, I think you're right.
Yeah, the earth next to you.
Totally think you're right.
Alright, let's see if we settle out. Okay. Good recovery. Somebody still needs to come up. I want to catch. Yeah, you gotta catch it. Yeah. Alright.
What's that again? Let's start with that.
What's that?
What's that came over there?
No. Alright, so what we got? Oh, it's right there.
Like that right there.
Yeah, do you want to try the port arm or try the front arm? Port arm will be easier once you get it to go to the area that you need to clean. However, it's tougher route. I mean, not that I don't have faith in you doing it, just saying.
Oh yeah, it's all about speed, but
No, it's
well,
about,
that's
you know, efficiency.
that's just
Not very good. Yeah. So whenever I'm doing a grab like this,
yeah.
I tend to use the sit cam or HG2 because it's easier for me to do my movements from the top down angle.
Gotcha.
But you do whatever works for you.
No, all tips are welcome.
Alright.
Alright, let's try the port arm.
Alright, now it's gonna be right next to the lid for 5 and also the monkey's fist. Not the greatest monkey's fist, and it's to the left. The easiest grab for this is going to be grab it like where it comes up. You know what I mean? Don't grab the T handle part. Grab the knife. No. It's how it comes off of the actual body of it like this and it goes back.
Gotcha.
Grab there. Just grab down on the knife. Okay. See the easiest way to grab it. To give you the most control.
I'm just saying that's this part right there.
Yep, right there. You can grab it over the tape and over the a little bit deeper.
Yeah, for those of you who are watching, welcome on board the Falcor 2 and the ROV SuBastian. We are doing work at the Western Galapagos vents and setting up to take one of the first gas-tight water samples from this vent field, actually the first gas-tight water sample from this vent field. This is work led by Dr. Jill McDermott, who is really interested in understanding how the chemistry of these vent fields, and she is directing the operations now in terms of trying to figure out which smoker to sample from. But maybe we can get her to tell us a little bit about the chemistry after we set up to do this. If you'll notice on the right-hand side of your screen, there's a big crab sitting in the background there. That is a crab called Cyanogrea. At least it was called Cyanogrea. The names are sometimes changed as we learn more about their molecular relationships. But I'll call it cyan. It'll always be Cyanogrea to me. They're one of the biggest crabs that live down here. They look a lot like Dungeness crab. They are blind, they have vestigial eyes, but they go around eating whatever I guess they can get their hands on. I believe they're sort of more scavenger oriented. They do have cousins called Bithagrea that tend to like to nip the plumes off of the tube worms. We have studied these, certainly I did as a graduate student, and Bithagrea are, they're cool crabs. They look like little albino Dungeness crabs, and they're capable of doing really neat things physiologically. They can deal with a whole lot of carbon dioxide in their bodies, like a lot of carbon dioxide, enough that it would kill us. Their bodies are physiologically able to not be poisoned by that amount of carbon dioxide. The reason we think they have this capability is it allows them to deal with the elevated CO2 in diffuse smokers, and so they can go in there, soak up a lot of CO2 as they are grazing, and then step back out and off-gas that CO2. Super cool. I don't know if we've done that work with Cyanogrea, but what I do know is that Cyanogrea are mean, and we would bring them onto the ship, and they just were absolutely committed to pinching you and pinching you hard.
Have you ever been pinched by one?
I have.
Oh no.
And I'm still holding a grudge.
No.
Right, now you can grab it however you want.
You actually have to check the basket really carefully.
Right, exactly. Right, Jill? Yeah, they are bad attitude.
Grab it back where you kind of where you had it.
What does the root cyano have to do in their name? What is that relating to?
First off, it is Cyana, C-Y-A-N-A.
Okay.
And I am not 100% sure of this, but I am willing to bet it is named after the submersible Cyana, which was used to do some missions of exploration in the 1970s. I don't recall if the Cyana submersible dove at hydrothermal vents, but it may have. It was a shallower diving submersible that I think was used by the famous Jacques Cousteau. So I think it's just named in honor of the Cyana submersible.
Gotcha. Not cyano like cyanobacteria.
I believe that's the case.
Blue.
My expert opinion, it might work.
That's all I asked for.
That's all you're gonna get.
That's all I received on the same page.
Alright. Yeah, give it a shot. I mean, all you're doing is cleaning stuff away. Alright, fortunate. Sorry, that was the weird spot.
Yeah, we're not sampling, we're just gonna use it as a tool.
Oh, I remember this. Yeah. Okay, my apologies. It's yeah, this did do dives looking for hydrothermal vents. So yeah, it's the French submersible Cyana, and it had a depth rating of, I believe, 3,000 meters. So there are a few websites that tell you a little bit more about this, which are really cool. I'm sort of looking around now, and it's jogging my memory. It's been a while since I thought about Cyana. While the pilots are setting up to clear this off, tell you that there were a good number of submersibles that were in use in the United States and in France throughout the 1970s and 80s and 90s. They continue to be used today. There's about just around 3 dozen research submersibles that are capable of deep dives. But back then the United States actually operated actually a good number, including Alvin and its cousins Seacliff and Turtle. And the French had a couple of France had a couple of submersibles as well, and they were used in some of the earliest discoveries of hydrothermal vents. Totally right. Yeah, that's kind of what I was wondering. I don't know what's happening here. Yeah. There.
Yeah. There's
So that's tiny.
It doesn't look like a big orifice.
Keep cleaning it a little bit.
be diminishing returns. It also doesn't look like. Just,
It's a lot of flow.
Even if we do get it clear, it's still going to be like
Yeah.
trying to sit through a straw.
Right. Do you want me to? Can I come wide on the camera?
Sure you can. It's round cloud. It's such a small flow.
Sometimes break them. That
So-
one might be more. Let's have a look at this right one and see.
Okay. Zooming in, and I'm going to take hands off the camera.
That one's about an inch.
Closer.
Hmm?
More closer.
Yeah, let's zoom in a little closer.
More arms, it's not sticking out of the flow.
It's more doable.
I mean, I'm no expert. It looks like there's more fluid.
That looks better. Let's go for this one.
All right.
Do you want to poke around a bit with the shovel and clear it, or what do you want to do?
Yeah.
Okay.
A little.
We're still gripping the shovel. Yeah.
Oh, okay. Like that?
Yeah.
Okay.
You gotta make the sound effect now. That's the rule.
Yeah.
You establish the baseline.
Make the sound effects. Like a sweepy sound?
It'd be real nice if it would crack at the base and give you a nice hard rim.
What's that sound on commercials when things are really clean? It goes bing. Make your teeth sparkly white. Bing.
Go down. Up. Okay. Are you gonna make the sound effect again? Okay. So all the way behind it, not in the hole.
Not in the hole, but all the way behind.
Try to tip the lid up.
Watch out for that crab.
Actually, close to the crab protection. Nice. Bigger shadows. I would push the arm down a little bit. Bring it in. A little bit down. So you
The
can
crabs
feel.
are hard to
You know what I'm saying?
you know how to
Short transmission
try to
out.
get.
I wouldn't have to shoulder up, just push it around.
Yeah, actually, JC just JC, who's a geologist with the USGS, just posed a really cool question. Like, she was saying, she imagines the crabs are hard to sample, so how do they do it? We often use crab traps, so we have literally crab traps that you would use. We try to get some that accommodate the size of these, and we bait those crab traps with canned mackerel, which apparently was a really popular, canned fish for many years. Nobody wants to eat mackerel anymore, so it's easy to find, at your neighborhood discount store. But yeah, we just,
Well, thanks, Tom, dude.
Yeah, that's good.
yeah, we
Just like
just,
regular crabs.
yeah, kind of, yeah. So that's what you do, just like regular crabs. It's pretty alarming. All right. Right there.
That looks better.
Oh, that's good. So that hole right there kind of wants you to yeah.
Glare.
It's a little stack of sulfite rocks.
Okay, sound effect. I know.
Start with that.
My bad, but that was pretty.
So JC, one of the things that I would love to see someone do, or I'd love to do if there was another me, is look at the metals in the crab's exoskeleton. So some of these crabs come up rusty looking and others don't. And you can see this sort of coloration on the cyanogrea's claw here, right?
Yeah.
And so crab shells are made of keratin, and a lot of them are also replete with calcium carbonate. That's what makes them hard. And keratin is, I'm sorry, chitin. I mean that. Crab shells are made of chitin. And chitin is functionally similar to keratin, right? It's like your fingernails, but it's structurally different. So here's this crab with this chitin shell that's got calcium carbonate in it. And people have done a number of studies looking at how chitin and similar polysaccharides adsorb metals. And so it's sort of interesting to think, like, does this shell play a role in adsorbing metals and keeping it out of the clam's tissues?
Yeah.
And I have no idea if that work's been done. I'm just sharing some thoughts that have crossed my mind as I looked at these discolored shells.
It's a really interesting crossover, yeah.
Good way to talk.
We've created a nice orifice, so we're going to set up to sample it.
Okay.
I think it's better to take the IGT and then take the super at this site because of the particles that we've kicked up.
Totally. All right, cool. Good news. So I'll post this on our group here to let everyone know.
Yeah, let all of our science team know. Yeah, I don't want to touch this.
Oh no! That was not what I wanted to do, but we'll see how that works out in the future. So just use your sit, go over there and drop it. But you want to kind of keep the T-handle on the edge so that you can pick it back up. You see that little notch right there? Yeah. If you place it in that notch, be a hero. Go ahead and turn IGT port on. Go ahead and turn it off.
Yes, you can go ahead. I misunderstood that I was on. Yeah. Yeah, we have good comms.
Right. A little worried because I think. Alright, so we need to pick that up. So I'll grab it with the starboard arm and then hand it off to you. Sounds good. Lock it off to the side. Probably gonna get it snatched there.
So continuing my nerd fest here about chitin, there are people really interested in thinking about chitin as a kind of metal absorbent and maybe for recovering metals from solutions, for example. So if you have an industrial process that leaves things like rare earth elements in solution, people want to find an inexpensive polysaccharide that you can put downstream and adsorb the metal, sort of pull it out of solution. And chitin's a candidate. There's a lot of research being done on chitin's efficacy in adsorbing different metals and so on and so forth. So I think these vent crabs have something to offer in terms of helping people see if that's a plausible scenario. And if it is, there is a lot of chitin in the ocean, and you know, even you can imagine food processors, you know, there is a market for chitin now that they recover from seafood like shrimp, and you know, it's used as an agricultural product and so on and so forth. But you can imagine that if people find that chitin's good at binding metals, it opens up a whole other market.
Yep. Doesn't be an issue, but we'll figure it out.
think I also read somewhere that chitin was used in bioplastics research, correct me if I'm wrong?
Oh, you're totally right. Yeah.
No, it's definitely very good.
Oh, that's cool, Sophia. Yeah.
Alright, so I need you to get there already.
Hmm.
You did a bunch of stuff on it.
Alright, so I need you to grab that, and then I might have to do something with the paddles.
Gotcha.
Those aren't. It's not.
Yeah. Yeah, one of our followers here on the dive streams said it would be interesting if they don't have chitin either. Or, I mean, if the chitins don't have metals in them. Yeah, completely agreed. Sophia, what are some of your favorite things about these vents? The
Oh my
ones we've been
gosh.
visiting.
So many things, it's hard to pick. I think for me, just the topography, like just the first, like the visual aspect when you first come up to one.
Yeah.
And especially if it's one you haven't really seen before,
Yeah.
you kind of like don't really know what it's gonna look like, because on the AUV map it's just like a little blob. I think that's really interesting for me, and then also seeing the diversity and also the disparity of the various communities that live on the vents. I was on the Lost City expedition, which went to the Mid-Atlantic Ridge, and just seeing the really big difference in how those communities look like is really interesting to me as well. Yeah.
Yeah, I completely that completely resonates. I'm curious, Dr. McDermott, what's because you've visited you've done a lot of work at the East Pacific Rise, which is kind of a comparison for this site. I mean, what do you think the most striking differences are to you?
Well, the one thing that jumps out to me is the scale of the structures. The chimneys here are taller. We saw one yesterday that was 30 meters from the bottom of it to the top, and that's a lot taller than any of the sulfide chimneys that I've seen at 9 North.
Yep.
The other thing that's really different about this site is the actual shape of the lava when you look at it in that view, and that's because this is not as fast a spreading center. This is what we call an intermediate spreading rate ridge, and so this one has a lower rate of volcanic eruptions compared to 9 degrees north latitude on the East Pacific Rise, which is also in the eastern tropical Pacific. But the reason this is important is the rate of volcanism has a big impact on how dynamic the vent fields are in terms of regrowth and recovery of the sites after catastrophic eruptions. So just to give you a sense of that, when I started my career, I studied 9 north latitude right after an eruption, right when everything was reset completely by volcanism. And so not only does that reset the animal communities, but it also covers up a lot of the sulfide structures, and those then can regrow over time. At that site at 9 North, we've seen 2 documented seafloor eruptions that were spaced 15 years apart. And so you can imagine that if the site gets reset every couple dozen years, then you're not really going to build up really, really large structures. And at this site here, the structures are much taller than those. What they have in common, though, is a lot of the same animal species seem to live in both places.
Yeah.
So it'll be really interesting to see whether there are any chemical drivers that are in common at 9 North versus this location.
That is yeah, it's really cool, right? Because I am by no means a card-carrying geologist or geochemist. So you're suggesting that, or asserting really, right? Saying that from your research, there may be some sites that are similar in chemistry, but the morphology of the vents is still really different. Is that? Did I hear you right?
Yes, that's right. Yep. Yeah, morphology does not necessarily correspond to a change in chemistry.
Oh, that's cool.
But possibly more of a change in the balance of the rate of volcanism versus
Got it.
the hotspots. hotspot also influence the rate of, yeah, I like the you want to tell the audience about the hotspot?
Alright, you want to just hold? And it was, alright, so now it's
So-
okay.
JC was commenting that we are also very close to the origin of a hotspot volcano, which is centered on the Galapagos Islands.
Hold it.
And so you can think of seafloor volcanism as having several different types of sources or drivers. And where we are right now is a spreading center, which has episodic volcanism as a consequence of plate tectonics. So we're at a divergent spreading center where new oceanic crust erupts episodically over time, and that's one type of volcanism. What's interesting about this site is it's close to a second type as well, at the Galapagos hotspot, which is centered right around the Galapagos Islands. Hotspot volcanoes are independent of plate boundaries, and so a well-known familiar hotspot volcano is Hawaii. It's also an intraplate or hotspot volcano that occurs in the center of a tectonic plate. What we have here is an interplate hotspot that happens to coincide with a ridge crest. And so the site we're at right now is also significantly shallower than the site that I study at 9 North, and that is due to the extra heat that's imparted by the hotspot. When you have more heat in the seafloor, just like heating up any material, the density of that material decreases. The density decreases, the crust inflates, and it results in a shallower vent field. So we are at a depth of 1,680 meters, and that is largely due to the coincidence of the hotspot volcano, which is right near this spreading center. What we're doing right now, if you're watching in the science cam, is the two circular items that are colored black and white are a type of modem that we use to communicate with the hydrothermal samplers. And one of the important tasks that our pilots are working on right now is they're making sure that the cables on the modems are allowing us to manipulate the sampler. So they were just rearranging those to make sure that we can reach the vent.
That crab is
Can I zoom? Can I zoom in on the crab? I'm sorry to interrupt, Jill.
Yeah, that's okay.
My apologies. The biologist in me just got a little crazy. If I can take over science cam?
Yep.
Thank you much. No. Where are you going? Good question. That is one tough-looking cyanogrea. Thank you, folks. So back to your regular modem show.
So, well, this I need. Let's go and let this go. It'll stay on. No. How close do these have to be? Have to be like a good contact, or
No.
near each
They have
other?
to be within like this far.
Okay.
One could actually be floating above the other. They don't have to physically touch.
Awesome.
Just have to be close enough.
Alright.
I think you're good.
Yeah.
The comms are solid right now, but even if they lift a little, it should be fine. Yep, I still have comms.
Alright.
You're good. Yeah.
Good catch, though.
But that's a good point, though.
Yeah.
We did.
Sorry about my confused thinking.
Fortunate. Alright, so
Good looking at this.
there we go.
Okay.
Right down there, right?
Yeah, that was it.
Alright, so
Right there.
we're gonna try to reach down there. Should be doable, if not, then I'll have to figure something else out. Go the other way with me. I gotta get jiggy with it now to the west so that worm. Light? I don't know how many ways are. It's just
What'd you see, Jill?
4.
4?
Mm-hmm.
Yeah, he's still pretty far away from that orifice. If you could spin it a little bit in your jaw, just try to get a better angle of the tip. And bring it closer to us at the wall, and then.
Could you spin it so the tip is vertical?
Yeah. Yeah. So, all right, bring it in. And closest to us.
Got it.
Yeah. Alright, and then rotate it. And then try to go out. Like so. Alright, so just do this. That one. In there. What I'm saying? Like before this one. Flip it up. There you go. And then extend it this way. Alright.
Oh.
Good.
Okay, a little bit more. Okay, bring your forearm in. Forearm in and yaw. Okay. One down.
7, 10, 16, 21, 26, 34, 40, 43, 45, 41, 46.
312 degrees. 312.
64, 77, 87, 97, 99, 103, 110, 113, coming down, 88, 77, 63, 62.
Oh.
Take it out while rotating the pilots. Can you give it a little shake?
Yep.
Thanks. I just like this short, just like right here. 16, 21, 25, 27, 26, 23, 25, 28, 29, 24. Oh, it's pretty hard in that spot. It was coming up. It was at 100.
Yeah, it was a bit in the grain though, Jill.
Yeah, I know.
Most that back wall to get that hot. Let me just give it a little shake.
Yeah.
A little like gain too.
It's a little less clear where it's coming from now. Should we try another? If there's another one to our right, that might be a little easier.
I just don't think I'm gonna get a very good iron sample.
Yeah, I don't think
And I need the iron that has to
Yeah.
the origin temperature.
Yeah, I see your point. I mean, Yep. 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 All right. Tyler, can you go ahead and pull the sampler away? We have another idea. I'm going to come wide on the camera if that's okay.
You see that one?
I hope that was all right.
You see
All
that
right.
little black one?
Yeah. Doug, can I zoom in on the one that Jill wants to get?
Yeah, I can see it down there.
Yep.
Let's take a look at this one.
Yep.
That line from where we're at.
Might be more.
Yep.
Kind of like stuff underneath now that we moved. I don't know if you have to reach to the one down there to the right. You see the black one? Yeah.
Tyler, would you like me to center it up on SciCam? Or what's better for you?
Mike's the chair now.
Oh, sorry, Mike. What do you want to do?
Yeah.
I want to knock off the little black
Understood.
bit
Understood.
before we put this stuff.
Understood.
With the other mist that was separated by that.
Got it.
Just clear out to the left just a little bit.
Thank you, Doug.
There you go. That was good. Oh, my up against the wall. Come on.
Oh, look at that. Some kind of stringy stuff. Welcome aboard Falcor 2 and ROV SuBastian. We are setting up to take the first high temperature fluid sample from these sites. And while we're doing that, you'll notice that there's all sorts of creepy crawlies living in and around these vents.
Happy with that?
Yep.
One of the challenges of taking these
Focus little vent.
high temperature samplers
But it is focused.
is getting the getting a good place to take a fluid sample that isn't compromised. And if you think about what these vents are, it's kind of like having a hot water hose at the bottom of a swimming pool, and your job is to figure out how to use a several ton remotely operated vehicle to put a little snorkel in that hot water hose and take a sample without sucking up swimming pool water. It's kind of what's going on here.
Honestly, you're like miles away.
The back of that thing.
Okay.
Against the rocks up there.
Yeah. As you twist, you're getting better and better. Yeah.
Ooh.
We're at 6 degrees, 8, 10, 13, 15, 17, 19, 27, coming up, 43, 46, 49. A little wiggle. Get it a little
Excuse me.
down a little lower. Yeah.
I'm sorry about that, folks.
48, 41.
There you go.
20, 47. Coming up. 85, 82, 69.
There it is.
64, 61. 60, 58. Yeah. 73, 81, 85. 99, 101, 103, 101. 50, 45, 61, coming up, 71, coming down, 36, 33, 27. 36, 50, 64, 84, 111, 138, hold it there, 187, 193, coming down, going up, 196, coming down, 160, 145, 140,
There it is. I think it's touching bottom.
Do you see where there's two orifices?
Yeah.
Should we try the one further back?
That's an interesting idea. Yeah.
So a little more focused.
Yeah.
I think it'll be easy.
Call it?
Yeah.
Tyler, I think Jill has another suggestion.
That's Mike now. We had a.
Oh, sorry.
It's Mike.
Hi, Mike. God, I'm like losing my mind. I look over. It sounds like someone new. It's like musical chairs in this room.
Ooh, it's hot there.
Oh.
Hold on.
Stand by.
Hold on. Lock that position. Going up. It's 205. Now it's coming down though.
Moved last time I did it.
Yeah.
Let's try and hold it.
All right. You want to try that further back one?
Yeah. What do you think?
Yeah. Let's give it a try.
Do you mean the one on the left-hand side? That looks
No.
like a little worm tube. You mean the little
No.
focused one in the back?
The focused one just behind where we had it.
Right. You see that one there, Mike? Can you see it on the?
Yeah.
There's a
Thank you, sir.
Second jet that looks a little stronger. That's a worm spa over there.
Right.
Yeah, so yeah, the one just behind it, you see?
Yeah.
Yep.
I know it's a little harder to see. Because the first one. 20, 22, 23, 24, 24, 26, 32, 45, 52, 62, 71, 82, 95, 103, 110, 119, coming up still, 147, 154, 161, 174, 184, 196, yeah, let's hold this one, 228, 236, 246, coming down a little, 226, 210, 182, 170, 156. So it's at least 246. Coming up, 205, 213, 226, 235, 248, 250, 260, 265.
Do I have a 280?
Coming down a little, 266. But it's holding pretty well. 269, 268, 259, 253. Coming up, 257, 258, 260. Alright, I'm gonna take the sample. You steady enough?
Yeah, I'm just
Okay.
holding it.
He's just gonna hold it.
Okay, just hold it. Alright, I'm sampling. Can you zoom out?
Yes. Okay, go ahead, Doug.
Take
Thank
a
you.
look at the motor.
What would you like to see?
Oh, we're out of the flow. Can you get that back in? It's 165. Can you give it a wiggle?
Yeah.
Okay. 160, 155, 139, 99. Can you give it another wiggle? 91. Coming up. Hold it right there. Yeah.
So,
Great.
probably not zoom, or probably can't keep the zoom on it. Try to stay as still as possible, but
Can you wiggle it again? Back down again. 55. There we go. 165. That's good. That's great. 221. 228. 232. 242. 250. 243. Coming up, 247, 251, 257, 261, 264, 265. Still filling, so that's good. 263. 269, 271, 275, 280.
My money's on 294.
285. That's our max so far.
Oh, come on, big money. 294.
Great, that one's closed. So before you withdraw it, can we take a picture? Zoom the camera, zoom the camera wide.
Wide?
Yeah,
Okay.
wide.
Let me get these lasers turned off too, so we don't have any information.
And then we can remember it forever.
Happy with that?
A little further back so we can see the chimney behind it. Yeah, that looks good.
Okay.
Great, thank you.
Clear to withdraw?
Yeah, you can stow the sampler.
You can breathe.
Yay!
Like tense.
And you know the better news is we're only taking one.
Yeah, exactly.
Yay!
My temp was 285. Yeah, it was
Push
285.
that forward
That was a
down.
T-max. You can also record that
This big sigh of relief
average
in the
during
control
testing
room.
was closer to 250.
Alright. You wanna push the
And
forward down?
yeah, the T-max was
You let me know when.
And then before we leave, can we drop a marker here? Maybe call it
Roger that. You want-
Chimlet 1 IGT.
Roger that.
You ready?
Chimlet 1 IGT.
Yeah, I'm ready.
Okay.
Now
Then if we want another sampler, it would be
Chimlet 1 IGT.
oh, sorry, chimney 1. No, what do we call it? Smoker 1?
This is, we are at Smoker 1,
Yeah.
right?
That's about all I can go.
So we're at Smoker 1.
Yeah, so Smoker 1, could we call it Smoker 1 IGT 3? I just want to remember what part of Smoker 1 did we take here.
Do you want me to,
Yeah.
I'll write it in the notes here, but let's see if we can get it in the name of the road. So Smoker 1.
Yeah, you grab the rope, it's got a little bit more flexibility.
Okay.
I mean, man, we make a marker that is short.
So we could just call it IGT 3.
Yeah, so you tell me what you want.
How about, why don't we just call it central number?
Okay.
So that's S564 IGT 3.
Uh-huh.
Marker.
Yeah, open up.
Then there's no ambiguity.
Yeah, that's a good point.
Wrap this camera back in. You just run that camera for me, alright?
Yeah.
Trying to get this key on inside the box. About all it wants to do there.
Jill, while they're stowing this, some of the folks online are asking if there's a potential for hydrocarbons in these vents.
Yeah. Effectively, all vents have hydrocarbons all over the world, and that's one of the things I measure in my lab. We measure hydrocarbons in all kinds of different vents all over the world. This site here will, so far we've been measuring methane on board, which is one of the simplest hydrocarbons with just one carbon. And one of the features of these vents is because they are so hot, they can exceed 300 degrees Celsius, for example, in this location. Because they're so hot, they tend to break down organic matter into simpler molecules like methane. And so the most abundant hydrocarbon in these fluids is methane. And that's what we measure here on board the ship. In addition, we're taking samples to take home to my lab at Lehigh University.
and we'll be measuring those samples for less abundant hydrocarbons. We measure other N-alkanes that contain more carbon, like ethane, propane, and butane on those samples. And then we're also measuring alkenes that have double bonds in them, as well as things like benzene. And we do scans for more complex hydrocarbons, but they are in much smaller abundances in the site, in these basaltic sites that you're seeing here. And that's because those really large molecules aren't stable. They don't stay together at such high temperatures. They break down into smaller components, which are the most abundant types of hydrocarbons.
I don't think I ever knew that, Jill. I never really processed the idea that all vents have hydrocarbons, because I can imagine that's true, right? To some degree.
Everything has hydrocarbons.
Yeah, pretty much. Like it's kind of a.
It's just a matter of.
It's like a planet. Exactly. It's like a planet thing.
This air has hydrocarbons.
Yeah, good point.
All right, what's next?
But these vents are pretty rich.
Nice.
Can we drop the marker?
Indeed, folks. I would like to drop a marker here. We're going to give it this name, S564 IGT3.
Thanks. So what I'm going to do with that sample is check it out on the GC tomorrow, and if it's different than the other smoker that we've been sampling, we'll return here on a later dive and collect them here.
Cool.
What was that name again?
S564
S. Yep.
IGT 3.
There you go.
All right.
Thank you. Now we're on to super.
And we are now, oh, your favorite, folks, we are on to super sampling. So, I mean, this is the bee's knees of the dive.
We can power the super on. It's not already on.
Minna? Minna here?
Yes.
Hi there.
Hi.
Would you like to decide where to go?
Yeah, so we're at, which chimney?
Super's on.
We are at Chimney 1.
Chimney 1, okay. So we want to get a near orifice and a midpoint flume.
Roger that.
We can start with the near orifice, or what, I guess whatever's easier.
Roger that. And no RNA later for either.
Correct.
Roger that. All right, sir. So may I pan down or tilt down on the SciCam?
Sure.
All right, so we are, let's go down and see where we sampled here. So we sampled that, right? Is that what we sampled? Yeah, we sampled that, right?
Yeah.
A little back on that. So Minna, what's considered near plume?
Near orifice is considered 1 to 5 meters above the chimney orifice.
So let's aim for right about there. You think that's about a meter, Doug? Maybe a little less, ballpark?
I can throw the laser on.
Yeah, let's take a really rough guess. All right, I'm gonna go ahead and pan over. Roger that. I'm gonna pan over with the lasers. So that's 10 centimeters.
I'm interested.
1, 2. I don't know, like
Yeah, probably right about there.
Let's go right in there. Cool. All right, Minna. I'm going to center up on the screen the spot we're going to do the super at. This is about 1 meter off bottom.
Okay.
And I'm going to kind of come wide on the camera. Oh, are we already at the widest? So
we're looking to 1 to 5 meters, right?
Yeah.
1 to 5 meters above that. Then?
That's right. I picked 1 since they said 1 to 5, and I figured that's reasonable.
1 is reasonable.
Yeah.
Would
And
it
it's,
be easy enough to have the temperature one next to it so we can record?
Roger that.
You want the temp?
Yes, please. If you have a chance to temp probe, just near that crack.
Okay. Pete, I'm going to leave you to this.
Okay.
Okay. Can you give me a call?
Yeah.
I'm interested in 1 sample at smoker 3.
Roger that.
When you're all set with this chimney, that's what's coming next.
Yeah. So thinking about the, wanting to stick to the dive plan, but also order of operations. How about we swing around smoker 2 and take a quick look?
Okay.
And then go straight to chimney 3 and set up for the IGT. And that gets that done hopefully before 1 a.m. or something like that.
Yes.
Okay, cool. We'll do that.
I'm gonna go to sleep. Don't hesitate to wake me up.
Won't do. Won't hesitate. I'll find you.
I'll put it on a sticky note.
Okay, cool. Thanks, friend. You got it.
Dig it deeper into the rock there.
Sorry, I know I asked already. Which chimney number is this?
It's quite okay. This is Chimney 1.
I assume we aren't going to get to it during
So you see the crack pretty much in the middle of the screen.
or
That's where you're shooting for. Right where it kind of lays
That's
your
right.
shoot right now.
if we're
Then you're
passing
gonna
that
get
one.
super out, so you're gonna have
Just like
So,
to just spin the probe to get into the exposed. Then once you're settled like this here,
So you want me to just leave this here, or you want to go
no,
like that?
no, you see, you gotta go near the crack with that.
Okay.
So you might have to split it and
Yeah, sorry.
maybe we step in next to watch.
right behind your jaw.
yeah, I think that's way next to
So as you come back, you see it right there.
That'd be great. I'll let Caitlin know.
So once you get it close to there, then I'll go ahead and move the.
Oh, yeah, she can do this.
Yeah.
You're at.
That's a total
I
kick.
forgot that you and
Is that a good temp for your feet?
What's
Right
that?
around there, 4 degrees?
Minna, 4 sound okay to you? 4 degrees C?
Yeah, I'm
For-
just mostly curious to
5, yeah.
keep the temp probe next to it.
Yep.
So we can see how it fluctuates over the
Perfect.
period, but we're not trying to hit any particular
Perfect.
range.
Perfect. So, this seems like a neat temperature to sample at, if you agree?
Yeah.
Okay, cool. All right, that looks great, folks.
Yeah, happy there?
Very happy, like
Okay.
beyond words.
What super number is this?
It's gonna be 4.
While the pilots are setting up here, some of our friends online were
No,
talking
like, I
about
haven't done one yet.
oil bubbles,
Superstar.
maybe seeing some here, and wondering if it's from the arm or something like that, but also remembering it being abundant in Pescadero. Yeah, it is very abundant in Pescadero. There are vent sites that are really replete with methane and with higher hydrocarbons, including petroleum. The Iguanas Basin is known to be one of those sites. So I think when you are watching the dive stream and you hear the name of the site, you have an opportunity to go to your favorite academic search engine and search for that name. For example, Iguanas Basin hydrocarbons. And I suspect you'll find a scientific publication that'll tell you about the kinds of hydrocarbons found in those sites. Again, Iguanas is well known for that. There's another one off the coast of Canada and the sort of Washington-Canadian border, a site called Middle Valley.
All right, we're set. If you're
All right, so
with that position.
yeah, we're holding at about 3.5 degrees C.
Alright.
So if you're happy, Minna, let's do it.
Yeah, so we can start
All right.
the event. Ready? 1, 2, 3.
Temperatures, yeah, it's cool, Minna. Temperatures sort of fluctuating between 3.96 and 4.1. And yeah, it might be, stand by.
Stand by, sorry. Around there.
Minna, are you able to shut it down? Oh,
We got
ouch.
to kill the super.
We got a little out of joint here.
I can't pull out.
Yeah,
Luckily we're in the bypass mode, so we can probably just do another bypass afterwards.
So that's what we do with that.
Yeah. Because we want it to be, well, we also don't want to be should be fine. I think I'm just like hyper nervous because of the ash and things like that.
We're repositioning. So, should I cancel this one?
Yeah, you can cancel it. Yeah. You can make it like it's just an observation that we started pumping, we started purging, but then we're gonna re-purge because
You have to get situated.
was the super killed or is it still on?
It's still on, I believe.
Wait, but I'm seeing oh, because it says complete. Oh, it just complete. It's normal for Let's zoom out with the camera and estimate the height.
No, it's quite tall. Do you want us to fly to the top of it and get a height? I mean, obviously when we're done.
If it won't take too much time,
I don't think so.
that would be great.
You bet.
Preservation.
No, it'll be regular. And then in the notes, you can say purged for 2 minutes.
There you go.
And once it's done,
Oh, yeah.
what that volume is. Good. 2 minutes.
Oh, check out the shrimp. They're all kind of
Say
bystanders,
Just gotta have an audience.
right?
Fight night.
Ding, 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 ding.
Go for something more yellow.
High ground.
The high ground.
Go for the underdog.
All right, folks, let's get ready to rumble.
What types of chemosynthetic animals were around this vent?
I don't recall. So, well, chemosynthetic animals. You mean like the big ones, mussels, clams, and the like?
Yeah.
I did not recall seeing any, but my memory may be
Were
faulty
there just
here.
no vents in the area to choose from that had animals?
There we go.
We flew straight to here because there was a request for an IGT and a super, but well,
Was Roxanne aware that there weren't animals around here?
yeah. So I told Roxanne. I see. We're talking about the animal sampling.
Well, I'm talking about Roxanne wants super samples at the chimneys to ideally, if we have the choice, for them to be around the chemosynthetic animals.
Right. So So Roxanne asked me to take an IGT here.
Okay.
At the 2 spots, and then I told her after we finish this, we'll go to Chimney 2, and we're looking for a diffuse flow with chemosynthetic animals along the way. And if we find it, then we're gonna do Niskins and another super, I believe. Does that sound right, Minna?
Sure. Yeah.
Yeah. So if you notice on the dive plan, everything from 10 to 13, we have put on pause until we get this done.
Okay. So for these chimney samples, she isn't. Okay. So now you go into sample 4 yet, and change the time.
Yeah, thanks for asking. This was something that was on the WhatsApp chat where Roxy did ask for that.
Okay. Yeah, we'll see. Yes, yes. We've been doing something. Yeah. So you hit hunt, and then you'll communicate to the sea logger approximately the time you started pumping. So you hit okay. So you'll log the additional text.
All right, folks who are joining us with the dive stream, if you want to send in your commentaries about this crab kerfuffle, please feel free to do so.
You can note that we don't see.
So a lot of the animals at vents, a lot of the crabs at vents can be a little bit territorial, but it's not just crabs. The limpets, I believe at vents can be territorial. I know limpets in the intertidal zone definitely can be. And so at vents, most of the microbial life is in and around vents where there's enough sulfide and methane and all those chemicals that fuel the habitat, right? So if you're an animal that grazes on microbes, you can see how it might be advantageous to find a spot where lots of microbes grow that you can graze on, and you can see how someone might come along and try to boot you out. All right, so one of the crabs is named Timmy. Who's Timmy? May I tilt the camera down, guys? Oh, all right. Oh, I understand. That's fine.
I said like crab induced before.
Kind of. There we go. We can kind of. That's a good idea. All right. All right. Oh, what's happening here? You got so shrimp's going for a ride. Yellow crab's picking a fight with a little crab. That's kind of a bully move right there. You know, as a biologist who studies animals and microbes, and a biologist who studies the biogeochemical cycles in these kinds of ecosystems, you know, I think a lot about where microbes and animals are getting their energy from, how they make a living, and all that. But every once in a while, I kind of wonder, what would it be like to be able to walk along the seafloor at a hydrothermal vent? You know, go for a stroll, because I wonder if these rocks are warm. Some of them probably are, and some of them aren't. I know from working with lots of ROV pilots that sometimes they touch a probe to a rock, and you know, the temperature goes up to 10 or 20, which is, you know, the sort of 50 to 70 degree C range, or Fahrenheit range. But a lot of them are cold. I'd be really curious, you know, what's it like for a crab going for a walk on here?
Pete, did you hear my experience? I was sampling some sulfides from Escanaba.
No. What happened, JC?
We froze our rocks when we got back, you know, to keep them from oxidizing, and then when we were sampling, we were freeze drying them to dry them without exposing to oxygen.
Right.
And I've done it with lots of samples, but there's this one where I took it out and I was grabbing it with gloves on, and I was like, this rock feels kind of warm.
What?
And I like touched it to like my wrist, and I felt it, and I was like, this rock's getting really warm. And so when I was transferring the rock from the freeze drying container to our shatter box,
right,
it rapidly started exothermically oxidizing, and it started smoking.
What?
And
no.
Yeah, I put it in the fume hood really quickly.
Yeah.
And I temped it at over 100 Celsius.
Are you kidding?
So.
All right, so just to be clear, that isn't heat from radioactive decay, it's a chemical reaction.
Yeah.
Do you know what was happening?
So pyrrhotite is known to exothermically oxidize. I think.
Like a hand warmer.
Huh?
The same way a hand warmer does.
Yeah.
Like you mix two chemicals and it starts to give off heat.
Yeah. So I think it was something about the rapid mechanical weathering. It was me like taking it out of a no oxygen environment and then breaking it with my hands. I think I exposed some surface area that.
That is crazy. So was that a little worrisome?
Yeah, it was not in the job description.
Right. Like, how do you file a workers' comp for that?
I did not. We were actually very excited.
Oh man.
So and it happened twice, actually.
That is completely cool.
So.
It's not naturally occurring thermite, right?
Yeah. Yes. Well, we won't talk about that here.
So hoping it doesn't happen.
Holes in the boat.
Yeah. Right. Exactly.
Yes, we are still taking.
JC, that's really cool.
Yeah, it happened. I'm glad it happened again with Kaylin around, so I wasn't crazy.
Amazing.
Looks like Timmy won.
I think so. What if those little shrimps are like the refs? Back to your corners. Right. I mean, are you happy with this so far? holding at about 8. It looks like it's kind of, can you see the little grayscale chart under there? That kind of tells you the highs and lows, right?
Uh-huh.
Like that little thing, Minna?
Yeah.
Sort of tracking temperature. So it looks like, right? So it looks like 12 is about your high, and I think this one was down about 8.
Okay.
Oh man, JC, I'm going to be thinking about that. That's so crazy. I don't know that I would have known what to do.
What rock was it? Somebody's asking. What type of rock was it? What type of
It was a sulfide. I don't know specifically, like, we just sent some rocks off into chemistry, so we're still getting back later from those. But it was part of an inactive chimney.
Wow. Huh.
And yeah, no, I wasn't sure what to do, so I just ran it over. I got my phone out, took a video, and I ran it to the hood. I hope maybe it's not.
Yeah, well, it's
No, we've talked about trying to recreate it because we want to like get the gases that are coming off of that too. But
right.
Yeah. But now I always don't trust rocks after I took them off the freezer.
Oh, I believe it. I don't blame you.
Hold them in my hands for a second. And I'm like, okay.
I don't blame you. The not quite as dramatic, but still startling. In the South Pacific, there are these vents in the Lau Basin. That's the kind of area of water between Tonga and Fiji. And they don't have riftia tube worms there. They have these snails called Alvinaconcha. They're about the size of maybe a little bigger than a golf ball, and they've got all these cool spikes on the outside. Dr. Roxanne Beinert, who is now our co-chief scientist, was working with me as a graduate student in 2009 when we went to sea. And she's done some awesome work on Alvinaconcha, which I'll tell you about later. But the point of this story is I dried out some of those cool spiky shells, put them in my office. I had 2 of them, and they, about a year and a half or 2 years after doing this, I was just chatting with a student, and one of them spontaneously exploded. It's like, what in the world? It just literally went and shot shards of shell everywhere. And I could not for the life of me figure it out. And the other one was sitting there, and I'm looking at it, I'm like, when's this gonna go off? But I figured I'd grab it, and I did the safety thing, put the glasses on, got the fat gloves, took it in the lab and poked at it a bit, and sure enough, it exploded. What's happening is the shell of Alvinaconcha is made out of, calcium carbonate, but they have a skin on the outside. The skin has all those cool spikes, and they dry at different rates. And so what I think was happening is the skin was drying and maybe contracting more than the carbonate shell and pulling attention on it. So, you could flick it and it would just explode, and we've reproduced that a few times. Take the shells, dry them out for a couple weeks, give them a flick, and then they explode like a little tiny firecracker.
That makes sense.
But it's, it's fun talking to students or sitting in your office, like, is doing deep sea research safe? Oh yeah, it's a blast, don't you worry about a thing. This little shell goes off. I mean, the number of students who come out with us and asked about safety, and then, something happens. It's not really dangerous, but just startling. It's like, I got dozens of those stories.
It was for my situation, Amy was actually in Jamaica attending ISA. So I had to WhatsApp her and just hope she responded. I was actually by myself. Or my team wasn't in that day, in person. So.
Yeah, wow. Yeah, right? So. Oh, wow. Oh, that is very cool.
And then I cleared out the rest of the stuff, and then I...
Whoa. Holy cow.
And it just
Wow, that's amazing.
It might have started heating up the ceramic bowl, so probably...
Oh, wow, look at that. Folks at home, I'm oohing and awing over a video that JC's showing me, showing this rock she mentioned in a fume hood, and she's taking the temperature, and it goes all the way up until it's out of range. This little digital temperature probe, so.
I hope it doesn't happen. It's probably. I mean, 2 out of 60 rocks, so. What's the last one?
Minna, how you feeling about the super sampler?
Great. Still pumping though.
Roger that. Okay, you're at a higher temp now. It peaked at 16. Hi folks out there. Yes, it's Peter. My name's Pete Gerges. I'm out here as a scientist, a professor at Harvard University. My lab studies animal and microbial physiology and biogeochemistry. In a nutshell, what we're interested in learning is how do animals at deep sea habitats make a living? What do they eat? What do they breathe? How does the environment shape their activity? And in turn, how do microbes and animals reshape the environment? That's a lot of what we do. On this cruise, we're interested in studying how the animals deal with pH, right, which is acidity. And I just shared with you a little while ago that not a lot of these animals are super thermotolerant. Some of them are. Most
40.5
can live up to about, hot tub temperatures. But many of them are really good at dealing with sulfide, which is poisonous, believe it or not. And many are really good at dealing with acidity. And these vents are acidic. At least these vents. Many other vents are acidic too. Some are not, but these are definitely acidic. So we're out here looking at how those animals cope with the acidity of vent fluids.
So we're ready for mid-buoyant.
Cool.
Which is going to be, make sure you go back to the slide.
All right. Folks, do we want to come wide and reposition the super inlets?
Yeah, so this time we're going to go approximately 20 meters above the orifice.
Okay. So let's see, so we're at about, says we're 2 meters off bottom, we're at a depth of 1671. So Minna, you requested an estimated height of this chimney as well?
Yes.
All right, so maybe we can come up 20 meters and see if we're above the chimney, and if not, we can estimate later.
Go back the probes just now.
Thanks for the nice compliments, folks. I appreciate that. Some interesting questions here. What does the smoke smell like? Dr. Jill McDermott collects fluids like this in her IGTs, which it's an acronym. I believe it's something gas type. What's the I stand for? Isobaric. Thank you. Isobaric gas type. Okay, stand by, folks. We're kind of gaining some altitude here. All right. So Minna, we're about 2-3 meters up now.
Okay. Oh, there's some mussels up there?
Oh yeah, good call.
Okay.
Good call. Lots of mussels here. So this is interesting. It might be interesting to sample mussels here that are different than mussels on bottom. So yeah, let's come back to that after we do the super sample, okay? All right, so far this is about 6 meters tall. We're coming up on 7 meters. 8 meters. All right, top of the chimney is about 8 meters, folks. All right, while we're getting to our position, the question is, what does it smell like? It smells like hydrogen sulfide, which you may have smelled coming out of, sewers, sewer gas and the like, but it doesn't have that organic smell. It doesn't smell like sulfide in an outhouse or anything like that. It just smells like kind of sulfide and iron. I've come to love it. A lot of people hate it, but to me, it's just the smell of happiness. Yeah. All right, we're at about 22 meters. Minna, does this work for you, or is because we're still in the smoke?
Yeah.
Yeah? I don't know that there's a need to take the wand out.
Right.
Yeah. Are you all okay with that?
Yeah, it's fine.
Roger that. So, all right, let's get the super wand out. And do you want to? Oh, do we need you to take the super wand out? I don't know where it's situated on the basket.
It's just sticking out right in front of us.
Oh, yeah. Min, are you okay with that? Do you want to put eyes on it and decide?
It's, as long as it's in the plume.
Yeah, you call it, Min. It's not a big deal. You want
It's
to?
a little. I'm not totally sure if I have the best understanding of the depth perception of these videos.
It's hard, right? But we are at 20 meters, and it looks like
Plume?
well, it's wafting in and out, right?
Okay.
Is that fair, guys? Are we?
Yeah, it's definitely going to be doing that.
Okay.
Especially with the ROV thrusters.
Oh yeah, Roger that. So
You know, so it's going to dissipate.
great. So what I hear you saying is moving isn't going to make anything any better. We should sit here at 20 meters, and it'll waft in and out.
Should, yeah.
All right. Yeah, I think that makes sense. Okay. You good, Minna?
I want to flush the line again.
Okay.
You see it coming from the port.
Yeah, totally. Yeah, look at that. Oh, that's cool.
Yeah.
So you're going to stay in the back position. Let's try the next time.
All right, we're setting the super sampler up. Is it comparable to geysers or hot springs? Is a question on the chat here. Yeah, I guess so. Yeah, if you've ever smelled the kind of geyser or hot spring at Yellowstone, that's a really, really good comparison. Whole bunch of little swimming things here. I don't know who those are.
Talking about travels and everything, actually, Yellowstone was one of the highlights of my trip.
Yeah, I bet.
So amazing.
Right? Yellowstone is mind-blowing. And I love the fact, too, that, you know, when you go there and you listen to the guys, they're like, you know, you're sitting on a volcano and it's overdue for an eruption. I'm like, wait, what?
Right, you went in a little museum by the Old Faithful.
Yeah.
Right there, and they showed where they had an ROV go down in the lake.
Right.
Do some research. I thought that was really neat.
Isn't that cool?
Yeah.
That was definitely one of my aspirations years ago when I first set up the lab. I was like, I gotta go study Yellowstone. There is an institute, though, that really does a lot of work there. And it's kind of hard to get permits and all those things, right? So it sort of makes sense that an institute in Montana can build those relationships. But they're very understandably particular about who dives in what. You know, just to add a little bit more to that, a number of my colleagues who are faculty at Montana State are deep sea hydrothermal vent biologists and hot springs biologists, right? So they're there in Montana State, and they come out here every once in a while, but most of their work is at hot springs just outside the park, right? So there are ranchers who own big swatches of land for their cattle, and there's hot springs on them. And so they, you know, depending on their personalities, they either like rent access or they just let them in.
Oh, okay.
Mike, have you had a chance to visit Yellowstone or hot
No, I
springs?
haven't actually. I'd love to. Yeah.
Yeah.
That would be amazing.
Yeah.
It's one of the places on my bucket list for sure.
I understand. Well, I'm guessing from your accent here that you're not from France, and I'm curious if where you're from has hot springs.
There aren't any hot springs in Aberdeen, Scotland.
Right.
As far as I know.
As far as you know.
None that I've come across anyway.
No. There are amazing volcanic islands off Iona.
Oh yeah.
That are big. I think they're called columnar, like the word column, columnar basalt, and it looks like a stack of Lego bricks. It's super cool. I was there for a conference in Oban which was also a delight because I got to tour the distillery,
Yeah, nice.
which was amazing. I'll say it again, it was amazing.
What you can remember of it?
I can remember. I can remember walking in, and but the islands are really cool, Mike. It's like it's like this except up on land, you know. And
I'll have to go and visit.
it's good stuff.
I've been along a little bit of the west coast of Scotland, but not really travelled enough of it, and it's so close.
Yeah, I have a soft spot in my heart for Scotland. I really do.
Yeah.
Met some amazing people there. Yeah.
Mike not excluded.
Mike not excluded. That's right. Yeah, a thing on my bucket list is going to going to Iceland, right? It's Iceland or no? It's Iceland, I think, where the two continental plates meet. Oh my God, what's that place called? I got to look this up. But there's a place where you can, you know, I suppose you could go diving, but you could certainly go for a walk. And in one case, you're on one continental plate, and then you know you can walk, and you're on another. Yeah, it's kind of like the continental divide in the United States.
I heard Iceland is an amazing place to go and visit.
Right?
I know a few people that's went up there.
Yeah.
Says it's amazing.
Yeah, absolutely.
I think Montana and Iceland are my favorite places in the world.
Really?
Yeah.
Yeah, I can see that.
I mean, I also spent a lot of time in both, so it might be biased. But I think they're both very beautiful.
Yeah, this is what it's called. Let me see. Let me go look up information on this.
Yeah, I think I did forget to write super in the last one, but I'll add it in the comments. Thank you. I added it on the same. Yeah. After all that talk, I was like, that's a thing that I forgot.
It's totally okay.
All right, so on the note of Iceland, it's called the Silfra Fissure, and it's very clear water. You can apparently go snorkeling there, and the Silfra Fissure separates the North American and Eurasian plates. So literally while you're snorkeling there, you can be sitting above one plate and then snorkel to the next, which I just think is kind of cool.
That's a bit chilly, though.
I bet it's a bit chilly. So Minna, there's even some temperature fluctuations up here as the plume wafts by.
Okay.
So it looks like I thought I saw a peak somewhere around 3, but I missed it. But it might be high 2s. I love this temperature probe. You guys, Sebastian's got a great T-probe. Yeah, there's some questions about pH. I've been looking at the pH data, and the mussel beds, the pH data from the mussel beds, I think is pretty cool. So it's about a half a pH unit lower near the mussels than it is above the mussels. It could be because I was measuring a little bit of the diffuse flow that feeds the mussels, but a lot of my research as a graduate student was on bringing up tube worms and mussels and keeping them alive in pressure vessels in our mobile high pressure lab, which actually is now on version 4.0 and is here on Falcor 2. But I have titanium pressure vessels in there, pressurized aquaria, and I can put animals in there and give them water at hydrothermal vent-like conditions and then study how much they breathe. It's called respirometry. And so what I can tell you is that the tube worms, you know, I'd give them water at, say, pH of 7, which is neutral, and as they would breathe it, they would pump out so much acid from their microbes' metabolism that they would drop the pH to 6.4, which this is a logarithmic scale, so that is just a huge amount of acid. So, you know, everything is exponential on a pH scale, and the worms did this as the water was flowing past them. So, why, you might ask? Well, their symbionts are really good at feeding the worm, but one of the prices the worm pays for that is that they produce acidity, or hydrogen ions. So the worms evolved the ability to pump those out. Now, it can't just leak them out, because believe it or not, there's more hydrogen ions on the outside in some cases than the inside, but the point is the worm's able to pump this out and keep themselves from dying from blood acidity. It's pretty wild. Basic worms. Yeah, they are. The pH inside the tube worms and a lot of these vent animals hovers around 7.4. There's a lot of good biochemical reasons for that. And if the pH gets too low inside an animal, they suffer the same problem we do. It's called metabolic acidosis. And a lot of your proteins stop working, and it can actually kill you. That would be a cool bike tour through Iceland. Right. Could you imagine? No. It would be a cold one.
Actually, I've been not super cold, but 21 to 22 degrees.
No, I think the moment you get right here,
on layered up.
it's still kind of.
I feel like you're riding around at about 70 degrees.
I bet.
There's a couple of like
Turn into an incinerator.
Yeah, that's right. That's right. Yeah, you lose your heat exchanger. That's funny.
Do you get to go to bed after this? Do you get to go to bed after this?
Minna, what's our ETA? ETD, or what is it? ETC.
Started pumping at 4:58.
Okay.
4:58. Yeah. Okay. So we still have 10 minutes.
Okay.
We have a few more minutes.
Like you said, about 15, is that right? Or a little less?
Total pump time is 12 minutes.
Okay. No worries.
And we did it prior to the morning. So yes, in total it for the night.
Understood. Thank you.
We'll be done soon.
Got it. So, I think, just as a heads up, Doug, I think from here, we'll go to Chimney 2 or Marker 2. I think it's Marker 2, Chimney 2, something like that. Waypoint 2, is that it? I don't know. Where's a Chimney 2?
Why did you take
Smoker 2. It was somewhere nearby. That's what Chris said.
Somewhere nearby.
Okay. Yeah, roger that. Okay, so we're just going to do a flyby and take a look at it, and then we're going to head over to Smoker 3, which I think is about 75 meters to the northwest,
Yeah.
Yep.
And we're going to set up for an IGT there.
Okay.
And then after that, we got to get to Smoker 5.
Which is just due east of that.
Just due east, yep. And then I think we're going to do some work at Smoker 5. I just don't remember what. So I'll do a check with it. What's that, buddy? Oh, that's Amy's, right? Amy wants a flange. Oh,
okay.
all right. Should have known. I might have known. So while we're finishing up, guys, I have an idea to run by you. I don't know if it will solve a problem or not. So it's noticing the push cores are real hard in the sediment, right? Because they fall out so quick. Do you think there would be any value in taking a coral quiver to the push core? Like imagine you have a coral quiver, weight on the bottom, a little bit of a base, rubber stopper, right? It'll take some basket space, but if you offload it, do you think there's a chance that it's right next to it and you just go plop and then move it onto the basket?
You might get a little bit more, but even yesterday, the ones that I looked at, as we were pulling the core out nice and easy,
Yeah, they were
dropping out.
That's right. Now some today were a little stickier.
Okay.
So that's why I'm sort of torn, Doug. Like, you know, is this worth doing? I don't know. I don't know. Yeah, like you have a couple that are busted up, the coral quivers that leak. That we could drill a hole and put the stopper in the bottom. You know, or put the core quiver, if the push core quiver fits in there. But see, once I would take a push core quiver and do it. But I was wondering if you just had a sort of a plastic disc as a foot and, you know, a dive weight on the bottom. If you set it next to you for a difficult environment. But
That's a good idea.
That's storage.
Yeah, what's that?
The storage.
Yeah, right, exactly.
So you have to sacrifice one to get another.
That's exactly right. It really is storage, yep.
Yeah.
So,
Out of space.
I don't know if it's a good idea, but it's an idea. The good part remains to be
So
seen.
you done now?
Yeah, I wish there were a better way to do this, and I keep trying to think about, like in the lab, or if I'm doing this by hand on a beach, like beach sand somewhere, I push the core in, and then I take, you know, a sheet of sheet metal, and I take it underneath, you know, like on a sandy beach, I would go in there and slice under it and bring it up. And I was just imagining the other night, is there some sensible way for a really difficult environment like this?
I don't know, maybe
A bottom. We can kill the super.
Like a bottom with an iris?
turn the super
Yep,
off.
okay, super is off.
I feel like some sort of
It is
mechanical
turned
bottom.
off now.
Roger that.
And we could stow that in the temp probe, is that correct?
Let me do a double check. Minna, I think we're going to Smoker 3. No, we're going to do a flyby 2. Then we're going to go 3 and do an IGT. Are we slated to do a? Yeah, I think we should stow. Yeah, I think let's stow it all. Thanks. Do you know if we're going to do a super under 3?
Yeah.
From the dive plan, it looks like we are going to do a near Chimney sample. Where did the dive plan go? I just had it in my
Oh, sorry.
Oh, cool. You're allowed to make a dive plan too. On the dive plan, it looks like you would be sampling worms here. Oh, it's because you did the IGTs before the
Correct.
super?
That's exactly right. Yeah.
So then, did you already slurp animals at this chimney?
I have
For Nicole?
I have not slurped animals at this chimney.
Okay, so it looks like we're supposed to slurp worms for Nicole here, and then before we leave, we're supposed to back up 10 meters from the chimney and do another super sample. Didn't Amy slurp on her shift?
I thought Amy slurped on her shift.
She did, but I don't. So does that mean that we're not? Was that an opportunistic slurp, or was that replacing this slurp?
It's a good question. Guys, let's stand by for a second. So I'm going to go check on this. So Minna, you're reading off which bullet point? Instruction number 10 or 11?
No, so instruction number 17.
Slurp. Okay. Here, now someone scratched this out. It says prefers slump around Chimney 1. That's what mine says.
Okay, mine
Nobody did that on mine. So I guess in this case, we're just gonna,
Okay, so I'm
the
gonna,
IGTs are done, right?
Okay.
So we're gonna back up 10 meters from the chimney and do a super sample.
Okay, so we need
So I
to
guess we
keep
can
this
turn the
out.
super back on.
okay, now before we do that, it says back up 10 meters and do a super sample. Is that from this chimney or was that done at Chimlet 1? Do you
It
see
was
what I'm
not
saying?
done at Chimlet 1.
It was not done at Chimlet 1. Okay. So, let me do a double check here. So, okay, choose spot where it's warm, blah, blah, blah. Take IGTs. So check this out, Minna.
Am I too far along in the dive plan?
No, buddy. I think I understand what you're doing. So, we are now gonna go do a lap around Smoker 2, and then we're gonna go to Smoker 3 and do do instruction 15.
Oh, I see. Okay, so I was too far.
Yeah, so maybe what we should do is let's go ahead and resume. Let's head on back to Chimney 2. Or head towards Chimney 2, guys.
Can we stow the super?
Yes, please, stow everything. I'm sorry.
That's
Yep,
what we
appreciate it.
stopped on.
Yep,
We weren't sure.
I appreciate that. Yep.
Oh, I see. Okay, so things just, and then the animal sampling and all that was all rearranged. We have not done that yet.
Exactly.
Okay,
So
understood.
We'll pick that up after we do our flyby of 2. We get to 3, get an IGT, and then I think we have to come back to the animal stuff
Okay,
and do all that. And so then when we get to 3, that's where we do the super.
okay, got it. Do you know if any of these changes that are communicated to the watch lead get added to the online version of the dive plan? Or is that too much coordination?
I think
They
they've just
didn't
been
even get to
scribbling
the,
up
they didn't even
there.
get to the logger.
Okay.
Yeah, I'm
Okay.
pretty sure they don't, Minna, so.
Okay, that's okay. I was just curious if that's where I should be, if that's what I should be referencing instead of a particular.
I wonder if what we should do is actually write it into here, into the logs, just say we change the order of operations.
Mhm.
And I don't know if you two want to do this, but I can summarize the changes that we've done since the watch here.
Sure.
So,
I had that we were going to chimney, like the chimneys were going to. I just didn't have the sample.
Add to the dive summary.
yeah, so you're set in terms of having captured it.
I had that we
I
were
didn't
going
see it open.
chimney
So I went
1 and 3, and then after we were going to do 2 and
Yeah, I think,
yeah.
so let's actually just do a
Yes.
recap. So maybe we can just call this recap, right?
Yeah.
Recap colon. We went to,
Oh, we just
We
finished
just-
Chimlet 1 and Chimney.
correct, so we did Chimlet 1. And at Chimlet 1, we collected a large active sulfide and put it in the biobox. We also collected an RNA layer sample of Chimlet 1. We also, between IGT,
I can check.
I assume that
this is Chimney 1. We're still at Chimney 1.
we're at chimney 1.
Yeah, we did the IGT here, so yes, we did do it here. So we took an IGT,
We went to Chimney 1 and then.
we went to Chimney 1 and took an IGT of a little smoker at the base, right?
Yeah.
Okay. So when we go through my list here, we got those. High T sulfides with IGTs, got them. Okay. And then now we are going to, okay, before we say now, what else did we do? We did IGT. Then we did a super sampler, about a meter above. And the super sample, 20 meters above. And that's our recap of work at Chimney 1.
Yes.
And now, I think it's going to say we are transiting to Chimney 2.
No, we just did near Orvis and then
Cool. All right. So whenever you all think we're at Chimney 2, all right, let's do it. Yeah, a number of you are asking about why don't we try this or why don't we try that with sediments. Let's start with the slurp samplers. Slurp samplers could definitely suck up the sediments. However, Dr. Amy Gartman and the members of her team, including JC and Dr. Caitlin Bowman, are they need the core to be intact so they can see the structure from the bottom of the top to the bottom to the top of the core. So that's why we're trying to push core. If you push core sticky mud, it sticks. If you push core sand, it falls out. And a lot of the grains around here are much more like sand. Okay, so is this 2?
No, I just dropped back down one.
Yeah, no worries. No
I'm
worries.
using this as a reference.
Understood.
So yeah,
this side, approach over there.
Okay.
This guy to the
All right.
I'll start with where the launch point is there. Should get you straight back, or I can bring you past a little bit more if you like. Right, get that step up.
Should be all right.
So Pete,
Yes.
does that mean that there are many objectives before the next super sample?
Right.
Or should I still be present?
That's a good question. I think, let's think this through. So you're gonna go to Chimney 2, do a flyby. We're gonna go to Chimney 3, do an IGT. That's what Joe wants.
IGTs take like 20 minutes per IGT?
I think you're kind of off duty.
Okay.
So, because who's stepping in at midnight?
Johan and Katie can both have them.
Yeah.
Super. Okay.
Yeah, you should go get some rest.
Okay, cool. Thank you. I'm just going to finish setting this up.
Thank you.
And we'll go. This is much more like broken up this all.
I'm not near 2, but there's this structure here we haven't a marker at all for.
And you're nowhere near 2?
No, you can see 2 is up there.
Holy smokes.
20 meters away, so
Huh.
I can head up that way.
Why don't we do?
Here, you want me to put a marker here?
Well, yeah. Let's put a marker here.
All right.
And let's. Jeez, what do we call this?
Chimney 6?
Are we on Chimney 6? Or Smoker 6? I mean.
Smoker 6, I believe. Smoker 7.
Are we on Smoker 7?
That's Smoker 6. Yeah, you was oh yeah.
7?
Yeah, Smoker 7. Doug, can we drop down and just sort of pan up, rather tilt up or fly up the face of it? Sorry.
Yeah. start at the bottom.
Yeah, let's start at the bottom.
Map it out the structure. Just
More
on the left side.
flanges.
Good grief. Yeah, I see that. Oh, wow.
Yeah. This thing is. Wow. Curious.
Yeah, right? These are wild.
Any questions on the base here?
Brilliant. All right. Can I zoom? Well, now let's go and fly back up, kind of a little bit closer. Yeah.
Yeah, I'm gonna get a little bit closer.
Brilliant. I think that's great. And I'm gonna maybe iris down a tiny bit. No, that's a little much. Is that okay with you?
Good speed for you.
This is great. So we do see maybe some flanges here. We'll go all the way to the top. Oh wow. A couple of crabs way up here. All right.
King of the hill right there.
No kidding, right? All right. Let's hold for a second. One thing that I thought would be cool to do would be to take enough video to make a kind of do photogrammetry and make a mosaic.
Right.
And so let's try that on this structure. And the way to do that is just to kind of try and maintain the same distance at all time, and kind of fly up a face, lateral over, fly up a face, and do about 4 or 5 or 6 passes around the structure.
Okay.
Is that are you comfortable doing that here?
I can't get around this other side because I'll hit the one distance.
Then let's save.
You see what I'm saying?
Yeah, let's save it. Let's do it for another one. Understood. Let's do it another one. So let's, if we can, lateral over, and let's fly back down and just get an estimated height, and we'll move on.
Okay, you want to fly back down.
Yeah, so we're at about 7 meters. Yeah, and I have a feeling you're okay. So I think we'll bottom out at about 2 or something like that.
Yeah,
So.
roughly.
So, yeah, JC, if you could just make a note that, we kind of did a couple of flybys, top to bottom and bottom to top. And, lots of microbial mat, a lot of alvanella worms and other polychaetes, a lot of diffuse flows, a good number of flanges, and a good number of Cyanogrea crabs, including one at the top. And yeah, we're about bottom, and it's about, say about 6 meters or 5 meters. What do you think? Let's say 5 to 6. How's that? Thank you. 5 to 6 meters. Okay, cool. Thank you very much. Let's continue on to Smoker 2. Yeah, that's a flange right there. So if you can make a note, we just passed a flange. Big one, actually. I wonder if we were. Oh well, you got something off to the side.
Yeah.
Now it's.
This is where it's at on the sheet.
Well,
That's
maybe
when I
so.
followed that smoke is when I found 7 of that.
Right. I wonder. Well, let's see. Can we turn to our port? Or
What's that?
can you turn to the port? I mean, is it off to the port? Just trying to figure out where this smoke is coming from. Unless you think it's the one we just saw.
I think that's where it's coming from. I'm positive. Just looking around.
It has us at 4 or 3 meters. So we're pretty close to bottom now. Getting there anyway.
Yeah.
So maybe this is a little small one. I don't know. Okay, there you go. Right in front of you.
Alright.
So is that smoker 2? All right. Or are we back
I
at
guess
7?
It could be. No, I haven't gone back that far.
All right. So this is smoker 2.
Alrighty.
Okay. Cool. Yeah, that makes sense. All right. Let's lateral over and take a look at this one and see if this is one we could do a photo mosaic for.
This one in front of me? Or the one
No, the big one to the left.
This looks like the one where is that? And
It is?
that flange.
Yeah, there's that flange.
Yep.
Cool.
One where
Okay.
it's at.
Yeah, no kidding. All right.
You
So
see, we're back at smoker 7. We never did find smoker 2.
interesting. All right. Well, while we're at the flange, let's go ahead and kind of drop down a little bit and then point the camera up and see if we can look into that mirror pool. You have seen this before, Mike?
Yeah, I actually saw my first one yesterday.
Right? Oh, you haven't? Check this out. So yeah, so
Smoker 5 actually.
yeah, and when you're set up, if you don't mind, we'll zoom in. But these we call these things flanges, are like balconies that stick out of these structures, and hot water pools underneath,
Oh, yeah.
and it's a reflecting pool.
Very cool.
You can see ripples on it.
Yeah.
I think I'm seeing some crystals something too.
Yeah, I think you're right. Absolutely. Oh yeah, look at that. You can see the bottom, I think.
Yeah, now it's kind of exposed.
Yeah. Let's hold attitude here for just a bit if we can. I don't know if it's hard on the vehicle, but it'd be nice to try and frame it up and try different lighting and see if.
Yeah. I'll tell you what, it looks the coolest in the city right now.
Oh yeah. Wow. Yeah. Holy cow.
Then you can see the.
Is that an HD camera?
It is. It's not a 4K, but it is
Yeah.
an HD camera.
Yeah. Nice. Can we iris down on this? It can.
You can. Yeah, if you want to try and get the best picture possible with that. Oh, the iris.
Black
all the way
balance.
out. There you go. That's better.
Yeah.
A little bit. Get a crab up in there.
Yeah. How much control do you have over the sit cam?
Just that tilt.
Tilt. Roger that. Okay. Okay. Ooh, can I take side cam up?
Yeah, I'm trying to get you
Try it, I don't
super
think it'll-
settled in here.
I'm not sure if it'll come up.
No, that's fine. Oh yeah, is it going to be? I'll try. All right. Yeah, you're right. It's not going to go up much more. It's okay. Let me
Do you want me to come up a little?
let's do it. Let me zoom in a little bit and we'll fly up onto it.
And all the hydrothermal.
This is pretty good lighting. All right. So guys, we're setting up. If you could make a note, we're doing some filming. Let's go up nice and slow and then we'll fly right past it.
Is this filming for
Yep, filming for Dave.
We can mess around with it.
No, let's go. Let's just go ahead and hold this frame and let's fly right past it because the BBC loves these like smooth flyby shots. Okay. Go ahead and sort of fly up, and then we'll just fly and kind of fade into the water where you can't see the chimney anymore. And then we'll come back and check this out a bit. All right.
What'd you call that pool again?
Sorry?
What's the name of the pool?
Flange. Flange pool. All right, a little bit more, and then we'll fly right back down. Oh, I gotta channel my inner Dan Turner. And cut. All right, I'm going to drop back down and. Yeah, if y'all have ideas on lighting, let's set up and look at the flange pool and try different lighting.
Geology.
So this is confusing though. So if this is 7, is 2 a bum marker or?
No, I mean, I didn't see anything.
Right.
Did you get on top of that?
Maybe, right? Somewhere on the top. But I don't know. All right, so I think that's the flange, right? Yeah. JC, can you make a note in the log that we're not sure we found smoker 2? We called this smoker 7, but there's a little bit of uncertainty because smoker 2 wasn't there, but a bunch of basalt was.
Yeah.
All right, so this is a nice vehicle position. Let's try different lights. There we go.
There you go.
That's nice.
Yeah, that's pretty cool.
I'm gonna iris down a tiny bit, guys, if that's okay. Like that.
Yeah.
Check it out, folks.
Are we gonna go and check smoker 2 again? Past the ridge or no?
I'm sorry, one more. Oh, no, I don't think we will. I think I'll just take some nice images here. So let's sit here for just a minute.
Sure.
I'll hold on this for about a minute. I'll probably zoom in a little bit and pan around.
Okay.
Kind of try to pan in and out, and then we'll head on over to Chimney 3.
Okay.
The tilt seems to be a little less stable than pan, I think.
Okay.
What is this? This thing's smoking here.
What's that, bud?
This.
That little tiny.
This little spout.
Yeah, I think that's a tube worm tube. I'll zoom in on that in just a second. It looks like one of those alva. You're not talking about the rusty one, but the little one up top, right? Look like a little spout with smoke coming out?
Yeah.
Yeah, I think that was one of those alvanella tubes.
Would you consider getting a sample from here for Amy?
Happily, if you think Amy would want this, let's do it.
She requested a flange.
All right. Happy to do it, but bear in mind we don't have an IGT to go with this.
Don't know if that was a requirement.
Understood. We also, the bio box is full, so.
Okay.
No, I'm not saying no. I'm just, if it's okay that it lives on the porch, if there's room on the porch.
I think that's fine.
Okay. Let's come back to that. Okay, let me do a little bit of pan and, well, let me, what's that, bud? No, I think you're good. Let me try pan, just a kind of gentle pan. Let me maybe iris down a little bit so it doesn't blow out over here. Is it going to let me do that? All right, I'm going to just pan over. Let me bring it up a little bit. There we go. Kind of.
Might reflect off there.
Is there any way I can iris down even more here or no? Yeah, that's kind of a crummy shot. Let me go. All right, I'm going to do a slow pan here if I can. Yeah, that's, yeah, let me, I'm gonna go back. I'm gonna zoom in a little bit. Notice that it's spilling over here. You guys see that?
Yeah.
Isn't that wild? It's like an upside down waterfall.
Yeah.
I'm gonna zoom in a bit. See if I can get the white microbial mat out of the way. Could I get some help with focusing? Oh, does that look good to you guys? Looks pretty good.
Great.
Yeah? Yeah, I agree. That looks great. Let's sit here for a minute. Which one, bud?
Yeah, that's
The red, the little weird red octopusy thing that just pulled in? Yeah, those are the Alvanella worms, or Pompeii worms is their nickname.
If you want, we can try and bring the T4 around and see if those lights will shine off the pool.
Sure.
just I was ready to try and do it, but I don't know.
Yeah, give it a go.
Once I haven't,
Any chance
down there
that...
set.
Yeah, let's do that first, but I was going to ask about depth of field later, but go ahead. Yeah, those colors are crazy.
It'd be kind of hard because
Yep.
how low I am.
Understood. Well, that's kind of a neat shot. That is a really cool shot. Is there a manual focus?
Yes, we want it.
Yes, please. And is it the yeah, okay, it's the bottom knob, right?
I believe so.
Yeah, okay, I'm just gonna cut. Okay, there it is. Now I'm gonna try and focus on the pool only. There we go. Check it out, folks. Okay, I'm gonna tilt up.
Oh yeah, you can see all little sparkly.
Yeah. Yeah. I'm gonna come wide a bit on the camera, and maybe that'll help us frame it better. There we go. All right. I'm gonna try to zoom in. Come on, come on, be nice, camera. There we go. Let's see if I can zoom in, focus on that a little bit more. There we go. Okay, this is cool. You can see a little smoke coming off the side. Nope, wrong way, wrong way. There we go. Yeah, the tilt definitely likes to drift.
Yeah, when you get towards the upper limit.
Yeah, I can see that. Cool. This is a nice shot too. Can we sit here for a second?
Sure.
Let's do this. Oh yeah, that's awesome. Okay. Yeah, let's give this about 30 to 45 seconds.
That's how the lights and see what the lights actually get.
Yeah.
Minimal other lights.
It's just light. It's not all. This is all just I can't see it now, right? No, this is just
All right, in 10 seconds, Doug, can you fly in, and I'm going to try to tilt up and bring those crystals into focus. See if it'll do it. Yeah, take your time. Yep. Yep. All right. And then maybe let's drop down just a shade. All right, excellent. So I'm going to try to tilt up. Let me see if I can zoom in. Whoops. Let me back up and try that again with the zoom. Okay, here we go. Let me hold still. All right, going to zoom in slow. Guys, take a look at this. I'm going to try to focus on the crystals. Okay, God, that is crazy cool. Let's sit on this for 10 seconds. Come on, stop drifting. Ah, lazy camera. Ah.
Let it drift.
Yeah. Yeah, probably. If Dan were here, he'd be like, what are you doing? All right. Okay. Let me come wide. Little preacher battle. Whoa. Coming wide.
Bounce.
Yep. Let's try one more, and I'll see if I can get those crystals, and we'll move on. Can you lateral over a bit?
Sorry, Charles.
I'm sorry. You go.
I'd love to bring the camera in, so you don't have to look up as high to get the same angle. There's no way to do that. Gotcha. Did it put up and down?
Thank you, Chris.
Problem. Figure out the answer. Crossword.
What would you like, Pete?
Let's lateral over just a shade and see if we can take one more peek into the pool, and then we're going to move on. Okay, I'm going to try and zoom in a bit. Oh yeah, I think I can see if I can get those crystals in focus. Let me try one more with the manual focus here. No, other direction. There we go. All right. Back off a little bit. All right, back off a little bit. All right, well, let's go back to autofocus, and I'm going to come wide a bit. And I want to do one more thing. If we could set up to try to see the upside down waterfall, I don't know if it's going to work.
Where am I going?
Do you see right there? Are you able to? Sorry, I keep poking the damn screen. Any luck or no? I don't know what's beside or behind you.
A little bit of something here, all right?
Okay. All right. All right.
River, lead into it as well. Stream.
Nice. Any suggestions on how to keep that white from blowing out up there?
I'm not sure about that one.
Yeah, neither am I.
Just have to-
Yeah, is there a way to turn the brow lights down? Okay, this is very cool. I'm gonna try to. Oh, okay. Sit tight. Let's hold with this for a while. Okay, actually, let's hold with this. Let's take a minute of this, and then if we could turn those lights off again in 1 minute. Caitlin, we could sample a flange. There's no IGT.
It's coming down. You ready to go?
Yeah.
Well,
Dang it.
Oh, that's all right. That's all right. Oh, look, another upside down waterfall. Let's let this clear out and look at this one.
Is that on the fourth by chance?
All right. What can we do with the lights, folks? Anything we can do to lights up on the upper port side? Yeah, sure.
Yeah, but Amy did say they had said
Turn the uppers, the floods down.
that's why I don't think she cared about she should press she wants flange over the IGT.
So what do you think, Caitlin? So
So the previous flange that we were at, an IGT was done,
No, correct?
No.
I don't think so. Which
We
previous
did-
flange?
We just did an IGT and it should be one.
Yes, it's this one. We did a bunch of stuff. We did IGT. We got big sulfide. Enough for Amy and you all.
Chimney one was one.
Yeah, Chimney one.
This is our IGT. And then on your watch you did the next two IGTs.
We did one IGT.
The last one of this one.
No, we're doing one more.
So we did Chimney one, then did we go to Chimney two?
We went to Chimney one, and that was where we were
yes.
scraping.
No.
That's the scraping. That was Chimney.
Yeah,
Right?
and we did sample an active sulfide.
Oh, yeah, we haven't even seen two. We've seen seven. Yeah, right. So to recap, everyth's been at Chimney and then Chimney one. That's all.
There's no plan to do IGT.
Yeah. There's a plan to do an IGT at Chimney 3. Jill wants to repeat it there.
Okay. So I would love to grab a sample here.
Yeah? Okay, so it's your watch, so let me finish this, and I'll turn it over to you.
All right. Okay, nice. So, Doug, let's drop down. This lighting is great. Let's drop down and take a look under the flange, and then I'm going to turn it over to Caitlin, and she has a sampling plan. Okay. I'm going to tilt up a bit. I'm going to zoom in a bit.